Welcome to the Tools Setup section. In this section, I'm going to show you how to download and install all of the tools that we are going to use inside of this course. One of the very primary tools that we're going to be using is called JDK. It stands for Java Development Kit. And this is basically software that we're going to download that is going to allow us to develop Java programs. We're also going to use Intellij IDEA. Intellij IDEA is an IDE. IDE stands for Integrated Development Environment. You can basically think of it as a very fancy word processor that takes the code that we write and converts it into language that the computer can understand. It is extremely user-friendly. It has a free and paid edition. We're going to use the free edition. If you are very capable, you can use the paid edition as well. Both of them are phenomenal. It makes software development extremely easy. We're also going to use Maven. Maven is the standard package management tool for Java. It basically allows us to download code that other corporations or individuals have developed and reuse that code. For example, we're going to use Maven packages such as Selenium WebDriver, which has been developed by the Selenium community. We will just basically download it onto our computer and use all of the provided code. And also we will be using JUnit. JUnit is a unit testing framework. Why do we want to use unit testing frameworks in test automation? Well, it's because they already have so many phenomenal capabilities, such as reporting pass-fail status, having different kinds of assertions, having different kinds of reporting mechanisms. And so before, we used to need to recreate all of this functionality on our own, but now we have these beautiful libraries that exist, and JUnit is actually the most downloaded package in Java if you look on github.com, and so that is why we're going to be using it. JUnit is extremely easy to use, it is extremely user-friendly, and most importantly, it is thread safe out of the box. So whenever we need to do very complicated operations with it, JUnit is our tool. In this video, I'm going to show you how to install Java 11 long-term support for your Windows machine so that we can go ahead and get up and running with the latest test automation technologies. So what you want to do is go ahead and open up your PowerShell window. So we're going to open up our run and pick Windows PowerShell. Now, the very nice thing about Java is that it is very ubiquitous, and you likely already have it installed on your Windows 10 machine. So if we do Java-V version, you see here that we have this come up and this says 1.8.0_171. So this is actually Java version 8, which has been around for many years already, and it is very common, but we are actually going to upgrade to a newer version of Java. The Java version that we are going to be using is Java 11 because it has so many new features, so many more capabilities than Java 8 that we want to be using the latest and greatest technologies. And the other reason why we're going to be using Java 11 is because this is actually long-term support Java. So it's going to be supported for a number of years, which means that they're going to be making enhancements and they're going to be fixing bugs, and you won't have to worry that your software is going to get out of date. Now, there are later versions of Java. There's Java SE 14 now, which is the latest version because Java has been releasing at a pace of about one release every 6 months or so. There's always new updates. However, the unfortunate part with doing something like this is it's not long-term support, so we don't want to take that risk yet until a future time when a higher version becomes long-term support. So we're going to come here to this URL, which of course will be included in your course notes, and then we're going to click JDK download. So then it comes over here and you can see that Oracle tells us that the license has changed significantly. Ultimately, Java used to be completely free for everybody, but now Java is becoming a paid license. So if you want to use Java, you have to actually pay for it unless you're using it for non-commercial purposes, which is what we are doing. We are using it for learning purposes. So we can come down here and pick which version we want to download, right? So if you're on Windows, you're going to pick the appropriate one. So we're going to download this Windows 64-bit installer. And then we're going to click I reviewed, click download. And now at this point, Java is going to ask you to create a profile. I already have a profile, so I'm just going to log in. You go ahead and create an Oracle account. It's completely free, but they do want you to have an account to be using Java. So after you create an account and you click submit, your download will actually begin. And you can see that our download has started over here. And so once the download has finished, we can go ahead and open it up. And yes, we'll allow this application to make changes to our device. We'll step through the installation wizard. We will keep all of the defaults. And once this finishes installing, I'll join you back here. If your Java installation was successful, and if you didn't change the default locations of the installation, your Java will be located here. You can see we have JDK 11.0.7 over here. Now, next step is to add path variables to our environment variables. So go ahead back to your PowerShell window. Inside of your PowerShell window, type in sysdm.cpl. And that will open up this window. Next, we want to go to Advanced, Environment Variables. And we want to add a system environment variable for the path of Java. So let's grab this path here to our Java directory. And then come here, click New, in caps, write Java_home. And then we will put the variable value as this. Now this will point us to where is the Java home directory, and click OK. And now we can see that this has successfully been added as an environment system variable. Next, we want to add another variable, but this one we're not going to create a new one. We're going to use an existing one using the path variable here. We're going to click Edit. And then here you can see there's already a bunch of variables here. We're just going to do create new. And now we're going to use the variables here, not the hard-coded path. So you just do like that, Java_home, and then do another %sign. So this tells us that we're going to use the variable called Java home, and then instead of looking in the exact JDK 11.0.7 folder, we want to look inside of the bin. So we'll just do a slash here and do bin just like that. And so then this will use the Java home variable and go inside of the bin directory, and then click OK. Next, just make sure that you click OK here, click OK here. Let's go ahead and restart our PowerShell window, because if we don't, it's not going to be able to read the new Java variable. So we're going to open up our PowerShell window. So now let's just check that our installation was successful by running javac-version. The C stands for Java compiler. So we're going to run the Java compiler, and it returns version 11.0.7. Congratulations, you've successfully installed Java version 11. In this video, I'm going to show you how to download Intellij IDEA so we can do software development. This is an IDE, an integrated development environment that makes writing test automation code extremely easy. If you've ever used other IDEs in the past, such as Intellij or Eclipse or Visual Studio, you know that Intellij is one of the best software development experiences out there. It is created by a company called JetBrains that also create plugins such as ReSharper for Visual Studio, which is one of the most popular plugins for Visual Studio. And they also created the TeamCity, the continuous integration platform that is very well known as well. So Intellij, they've got a bunch of bright individuals out there creating phenomenal software. And Intellij IDEA is the best software to use for Java development. So you can come over to this website, and there are two versions that you can download. If you want, you can download the Ultimate Edition, which is a paid edition, but what you get with it is phenomenal and amazing. And I personally use the Ultimate Edition for production live software development and test automation. And also the latest version of Ultimate Intellij actually comes with some cool Selenium WebDriver support and tools. But if you don't want to do that, there is a community edition, which is exactly what we're going to use for this course, and it's absolutely free, and it's also phenomenal and perfectly capable of doing anything that we need for test automation. So I'm going to go ahead and click the Windows executable download, and then we're going to wait for that to download. And you can see over here the download has begun. Once it's over, let's rejoin together and we'll continue with the rest of the process. Okay, so we have the executable here. I'm going to go ahead and click it. Yes, we'll allow this to make changes to our operating system, and then we'll click next here. Yes, we'll just keep the default installation directory. And let's see. Yes, we'll add a 64-bit launcher shortcut. And let's go ahead and create the following associations for Java: Groovy, Kotlin, and Kotlin. These are just useful just in case we ever want to write Groovy or Kotlin code. And then this is all great. And we're going to click next, click install, and then we'll rejoin together once this installation has completed. So the installation has completed. We're going to click the Run Intellij IDEA Community Edition, click the Finish button. Here we are not going to import any Intellij IDEA settings because ultimately I'm assuming that you've never ran Intellij IDEA before. If you have, you can choose a previous configuration, but for our purposes, if you're starting out brand new, you're not going to import any settings, so we're just going to click OK. At this point, you get to choose a theme. I prefer usually the Darkular theme. However, I'm going to choose the light theme here because it's really nice in the videos, but you can obviously choose the one that you like best. Here we can select different kind of plugins. So we can leave all of these as they are because we are happy here. So we'll just hit next, feature plugins. And all of these plugins are fine. We don't need any of them right now. Excellent. So there it is. We've successfully installed Intellij IDEA, and now we need to configure it for our environment. In this video, I'm going to show you how to configure Intellij just to make it a little easier to use, and this actually applies to both Windows, Mac, and Linux, all three of those. So let's click Configure. We can go to Settings. And we're going to come to System Settings, Editor, General, Auto Import, and we are going to add unambiguous imports on the fly and optimize imports on the fly. Then we're going to go to Appearance. We're going to make sure that Show Line Numbers is checked. Then we're going to code folding, and we are going to uncheck one-line methods. We're going to uncheck imports. We're going to uncheck closures, and we're going to uncheck generic constructor and method parameters. We did that so our IDE is easier and more user-friendly. Next, we're going to come here to configure and structure for new projects. We're going to come here and select our SDK. So you should see that automatically we already have our Java 11 version. Now mine is 11.0.7, yours might be .8, yours might be 11.1, depending on when you install Java version 11. That's totally okay. Go ahead and pick that version, and now that should be good. And everything is all set for us to start using Intellij. In this video, I am going to show you how to install Maven. Maven is basically a plugin management software that we will use to manage all of our libraries that we download and work with in Java. So I searched for Maven download here in Google. The very first link that pops up is this one. So you can go ahead and come to this link. Here you can see all of the requirements for being able to use Maven. Obviously, as we already know, we have Java version 11 installed, and at the very minimum, you should have 1.7. And then you can come down here and download the appropriate binary. So I'm going to go ahead and download a zip. And if you're on Windows, you should do the same thing as well. Now that our zip has been extracted, you can see that I have this extracted folder here, and inside of it, we have this folder structure. Ultimately, we really care about the bin directory. So we don't want to leave this in the downloads folder, so we're actually going to move this to a safer location. So we're going to take this folder, I'm going to cut it, we're going to come to C, Program Files, and let's paste it here. And we'll say continue. Next, just as before, we need to add some environment variables to our system. So what we're going to do here is doing Control R. You can type in sysdm.cpl, and that will open our window right here. And then we can go to Advanced Environment Variables. And let's come, before we start creating environment variables, to our Apache Maven folder, step inside, make sure you can see the bin directory, and let's grab this path. And now let's create a brand new system variable. Come here, click New, and we're going to call it Maven Home. And the path will be this path here. Okay. And now we just need to add a path variable as well. So just as before, we are going to find our path variable. We're going to click Edit. We are going to add a new one. And then because we're going to be using a variable, we're going to wrap it in %signs. So we're going to do Maven Home. And then we need a %sign around that. And just like as with Java, we want to locate our bin directory instead. So ultimately, this Maven Home variable is matching up to the Maven Home variable that we added in here in our system variables. Okay, so let me show you that Maven Home variable that it's matching up to here. And then we're going to click OK. And then we're going to click OK as well. Now let's go ahead and verify our installation by, again, doing Windows R, typing in PowerShell. And I typed in power, which we don't have such a process on our system, PowerShell. And now we can do Maven -version. And we can see that we have Maven successfully installed. It says Maven Apache version 3.6.3. Congratulations. Okay, so enough installing stuff, right? When are we actually going to do something with all of this? Well, now I'm going to teach you how to download the source code for this project. So we are actually going to get the source code from version control. We can either create a new project, we can open or import a project if that already exists. For example, if you just download the source code from this course directly, which is available here in GitHub. However, it is available in GitHub, which makes it really easy for anyone to download. So obviously you can just download it as a zip file from here, but you don't have to do that because IntelliJ makes it really nice to get from version control. So you can come here, you can insert this URL in there, and then we're gonna put it into a directory of our choosing. I personally like to create a directory at the C source level, and then inside of there, I like to store all of my source code. So I'm gonna place it here and click OK. And then because of that, it will then create a new Selenium-Java directory. Let's go ahead and click clone. So after the Git cloning has completed, IntelliJ will finish up your installation and then it will pop up with a tip. I personally recommend that you keep these tips on because every time you open IntelliJ, you'll get a nice little tip that will help you to improve your productivity. So you go ahead and read it, write it down if you want, and then just move on. I'm gonna go ahead and click close here because I've read this tip and I'm happy with it. So now what you're going to see is here IntelliJ indexing all of your files is going to prepare your environment for first time use. So once it's done that, give it a few moments, and then when it's done, we'll come back together and I'll continue the process. So after IntelliJ finishes getting ready, the very first thing we always want to do is make sure that we can build a project. So you're going to come here to the build menu and click build project, and this will build the entire project and make sure that there are no compilation errors. After all, I am just a human and I can make errors. So if there are compilation issues, it's either a problem on my end or some problem with your environment configuration. Make sure you let me know if your project is not building, and we will help you to get this fixed. So now just a quick little overview of what's going on here. You can see that on the left-hand side, we have the project view. You can see that here we have some source code. If you expand it, you'll be able to see some acceptance tests, some tests that already kind of exist here. And furthermore, as we go through every single lecture and every single section, you will be able to access different parts of the source code. Now, the source code is going to be broken out into branches. So each section is going to have a corresponding branch. So for example, here you can see there are Selenium WebDriver actions. Here you will find Selenium WebDriver locators and so on and so forth. And so in order to be able to see the solutions to that code, you're going to need to be able to download that code, okay? And the way you do that is by simply selecting the branch that you want. And of course, I will always provide you a link, and you can see that now we are in this branch, and then you can clone or download that source code and you can see those solutions in there. Or if you don't want to clone or download it, you can actually just explore the code through here by following through different examples here and opening up and taking a look at the code this way if you prefer, whatever is your preference. And one other thing that I wanted to say is it's up to you how you want to work. I recommend that you use this as basically a template for yourself. You can feel free to create a totally new package here where you can work through your test code and then use all of the code that you see and that you download as a reference, and you code along, you write all the code yourself, and then use this code as a reference to make sure that you're doing everything correctly as the exercises specify. In this video, I am going to show you how to create your very first Maven project. So let's go ahead and open up our Intellij Community Edition. And if you've already had a project previously opened, you can see that it's loading my previously opened project. However, for you, I'm assuming that you've never opened a Java project before in Intellij, you're going to have the option to create a new project. So to do that, I'm going to go to File, New, Project. And you can see here that I have several options for creating different types of projects. We are going to create a Maven project. A Maven project is really nice because what it does is it comes with a special setup in the project directory that allows it to work with Maven, which is our plugin control/build tool. And so we're going to come here, we're going to click next, and so then you can give this project a name. I'm going to call it Selenium Java, and I personally like to save my projects in a source folder located at the root. So usually I have a C source directory, and in there I will put all of my source code, however that is related. So here I'll create a new folder and call it, and then we'll place that in here, and then we'll click finish. And of course, here are the tips of the day from Intellij. Very useful. And so now you can see that over here, what we have is our very first Maven project. If we, on the left-hand side, you can see the project outline. We can expand it, and in here there are several important folders. One of the most important folders is the source folder, again automatically provided to us because we chose a Maven project. And inside of this source folder we have a main and a test. We can expand the main and we can expand the test, and each of them has a Java folder. The main folder, we would put any kind of code that is core to the project. So for example, whenever we're doing test automation frameworks, we would put our page objects in here and other external classes inside of our main directory. Inside of our test directory, we would put, guess what? Our tests. So whenever we're writing our automated software tests, we will put them in here. We can mix, we can add other classes in here as well, just kind of as we're doing exercises, but ultimately, as a best practice, we want to separate the two and keep our test code in here and our core functionality in the Java folder. And so you'll see us creating all of our tests inside of this Java folder. Now, there's another very important file when it comes to Java programming, and that's the POM XML. The POM XML is what actually helps us to manage the different kinds of versions, different kinds of plugins, different kinds of libraries that we will use in our programming of our test automation code. So right away, automatically here, you can see that our POM XML is identifying the solution that we have, and it's saying that we have this group ID called org.example. It has this artifact ID, selenium.java, selenium-java, and then it has this version 1.0-snapshot. So these three unique attributes combine to create a unique key that if we ever decide to upload to Maven Central, for example, they will tell us this is the code that comes from this unique key. And here we will also be adding other libraries such as Selenium WebDriver, such as JUnit. We will put those libraries in here using XML syntax, and then automatically Maven will pull that down from Maven Central Repository, which lives in the cloud. It'll pull that code down to our machines so that we can use it. You'll see more of that as we continue the coding through here. The other really nice thing about having Maven is that now we can actually use it as a build tool to execute our tests and make sure that our code compiles. And if you ever decide to do stuff like continuous delivery, continuous integration, Maven is what you're ultimately going to use to, as I said, run tests and compile all of your code and make sure that everything is working. I'll show you an example of that now. Once you get to a stage where you actually have some code, you will be able to open up your terminal and run Maven test, and it will actually run all of your tests. You'll see in here is just running the few tests that we have, and you can actually give it a try yourself by going to our GitHub repository, downloading the source code, extracting the source code, and then opening up the project and doing Maven test, and it'll run some tests. Look at that, how awesome is that? And don't worry, we're gonna have you coding your first test very soon. Hello, and let's get your very first automated test running using Selenium WebDriver. The very first thing that you're going to need is a Chrome browser. You always want to make sure that you're on the latest version, which automatically updates anyway, but if you want to check what version you are on, you can come here to Settings, Help, and About Google Chrome, and it'll tell you which version you're on. You can see I am on version 80 and it's up to date. The next thing you're going to need is a Chromedriver. A Chromedriver is just an executable that allows Selenium WebDriver to communicate with the browser. Our code will send commands through the Chromedriver, which will then turn those commands into web requests that then the browser will use to understand and use our code to interact with the browser. For Chromedriver, you want to be using the Chromedriver that corresponds with the version of your browser. So I have Chrome version 80, and so I'm going to download Chromedriver version 80, as you can see. And so then we won't have any problems. So go ahead and download it. Once you download it, we're going to go ahead and open up Intellij. So in Intellij, you're going to take the driver that you downloaded. You're going to add a new folder here called resources. So as you can see, I already added it. You're just going to right click, new directory, and then you're just going to name it resources. And when you get the Chromedriver that you downloaded, you're just going to take it and drag it over to your resources folder and drop it right in there. And so then you're going to have this Chromedriver in this resources folder living as part of your project. So we are going to come to this folder, test Java, and we're going to add a new Java class. Right click, new Java class. And we're going to name this Hello Selenium Test. In order for our test automation to run using a tool like Maven, which we'll cover in a future portion, we need to have a test at the end, test or tests at the end of our class. And so we have to put test there. Next, we're going to create a new method. Just type this out with me. This is going to be our very first test. This is known as a method. This will be covered in a future portion, but right now we are just focused on getting you running your very first test. Next, you want to go ahead and write this line of code. So what we're doing here is we are actually telling our system where to find the Chromedriver resource. So we're setting a property, an environment variable in the system. We're saying where the Chromedriver is located, which is here relative to our project in this folder. And we're telling our system that it has this name. Next, you want to create a brand new driver. Let's go ahead and do that. So This code right here allows us to create a new Chromedriver. What you can see here is our IDE is highlighting this in red, saying that there are some problems. If you highlight over this, you can see that our IDE says cannot resolve symbol WebDriver. So we can actually use Intellij to help us solve this problem. If you see this light bulb, you can click it and it provides us a bunch of helpful ways to solve this problem. What we really want to do here is add a Maven dependency. So let's go ahead and add that. Many people, what they do is actually they don't know this shortcut, but they go online and they search for Maven packages rather than doing this way. So keep an eye out here. I'm teaching you a quick shortcut that will really be helpful. So we're going to search for an artifact and we're going to search for Selenium. And we get this list of different Selenium packages. The one we want is at the very top. We want to expand this and we want to get a version 3.14159. The current latest working version of Selenium is 3.14159. However, version 4 is coming out soon. 3.14159 does already support a lot of functionality from version 4. So everything I'm going to be teaching you here will be applicable for Selenium version 4. So you will be future-proof from the next Selenium versions where there will be a decent amount of changes. So we're going to add this here. We added it and I'll show you what happens in a second. And the other thing you can see here is our IDE now says, look, I need to fix this. So what I'm going to do here is press Option Enter. And this is going to allow me to import a class. Pay attention to what happens up here at the top when I do this. Importing a class simply says to the compiler that, hey, we are going to use this code from this package over here. And we're going to do the same thing with Chromedriver. Look, I'm doing Option Enter, and that will import this as well. So now I have two packages, these two Maven packages that were downloaded onto my computer. So this is code that the Selenium community has written that we now have on our local machine that we can utilize rather than writing that code ourselves. We basically downloaded packages of code that we can use in order to do automation. Not only with Selenium, we can do this with many other packages that exist in the world. And remember when we imported a Maven package, that actually went over here to a POM XML. You can see that in our POM XML, which is just a configuration file for our entire project, we got this new dependency here. This automatically got imported. This is what I was talking about, that people go online and search and copy this. We actually bypassed this with a quick little shortcut and made this happen really easily. So we just imported this Selenium package here. Let's go back to our test. I wanted to make one quick update about how to control the versions of your Chrome drivers, because I realized that some students are going to be taking this course on a Mac, others will be taking this on a Windows, and so it's very important to understand the difference of how to interact with the different Chrome driver versions. Now, I know that you saw me writing code on a Mac where I set the system properties like this. If you're on a Windows computer, which I'm going to assume most of you are, this is how you want to get to the path of your Chrome driver. And the other thing that I did here is actually in our resources folder, I created two separate folders. I created a Mac folder and I created a Windows folder. Why did I do that? Because actually the binaries that we download of Chromedriver are totally different for Mac and for Windows. So for example, look, if we go here and we download this version of Chrome, you will see that there's actually a Linux, Mac, and the Windows. So they're actually separate. So if you wanted to run my Mac Chromedriver on your Windows machine, it would not work. And so you need to download the appropriate version for your operating system. So I created a Mac folder here and put the Mac Chromedriver in here. So let's do the same thing with Windows. I'm going to download the Windows, come inside of our folder, and we have to make sure to extract it. So we're gonna right click, extract all, extract, and then, oops, we don't want to open it. So you can see that here is our Chromedriver. So all you actually have to do is pull up your Intellij and drag it over here. Let me minimize this just so that it's easier. And I'm going to take this Chromedriver and I'm just going to drag and drop it here into the Windows folder. And then here you can see it's asking if I want to move it. I'm going to say yes, I do want to move it. And now you can see, and I'm going to add it to source control. And now you can see that we have a Chromedriver for Windows and for Mac. So whichever one we decide to use, that's the one that we can use. And I showed you both of the ways. You can either go to Windows or you can go to Mac, and both of them will work. Now, in the videos, you will see me referencing this path because a lot of stuff I did on Mac and some other stuff I did on Windows. So don't worry about that. Just remember what is the correct way to set it, whether you're on Windows or on Mac, and the rest should work out totally fine. The other thing I added here as a note just to remember is to make sure that your Chromedriver and Chrome browser always stay up to date. It is very likely that one day you will open up your source code and your source code will no longer work. It will be getting some kind of weird errors. That's because your Chrome automatically auto-updates. Chrome always auto-updates. And sometimes it happens that the Chromedriver version, the older one, doesn't support the new Chrome browser. And so in which case you just need to go, download the latest Chromedriver, and then make sure that it runs. And then once it runs, all of your tests should be okay. So what you can probably tell by now is that managing local drivers is extremely painful, because what's going to happen is Chrome is going to automatically update, and when it does, you're going to need to go and download the latest executable, extract it, put it in your folder, and so on and so forth. And imagine now if you're trying to do this cross-browser, right? Maybe you're on a Mac and you want to execute on Chrome and Safari, the two most popular browsers. So there's a much better solution that I would like to show you, and that is using the WebDriver Manager Maven plugin. So what I've done here for you is I created a brand new class that is called Hello Selenium 2 Test. It's the same test as we've written before, but I wanted to show you an update on how we would use the WebDriver Manager in order to be able to automatically generate Chrome drivers and Safari drivers for us without having to do much work. Okay, so step number one is you're going to need to add it to your Maven POM XML. So let's go ahead and open up our POM XML here. And you can see that here we need to add this dependency that we can also find at this URL. This dependency will automatically manage our Chromedriver resources and any other WebDriver resources. Then we're going to need to add an import statement for the WebDriver Manager. And now in here, let me show you exactly how to use this WebDriver Manager. So we are going to have a before class method. This method, because of this annotation, will know that every time this class executes, it will run this line of code. Afterwards, it will start executing the logic that is in here. So let's go ahead and actually run through the code so that you can see step by step as it executes and exactly what happens. So what we're going to do here is click here in the gray space to add a breakpoint. This will force our code to stop here and wait for our command. And we're also going to add a breakpoint inside of this method as well. Now, we're going to come here to this arrow, we're going to click it, and we're going to click Debug Start Smarter Test. and that's going to run. And you can see that now our execution has stopped on this line of code, line number 12. You can see the blue highlight and the red dot, and that tells us that our code is stopped and is waiting for our command. And down here, we can do a bunch of the debugging commands. So I'm going to actually run this line of code so that it will execute until the next breakpoint. And what you're going to see happens here is, using the WebDriver manager, we're going to set up our Chromedriver. And so this will automatically pull down the correct Chromedriver based on your Chrome browser version, and we'll set it up. You don't need to worry about which version of Chrome we have and which Chromedriver we need. And so now we're going to run this line of code, and then it will stop at this next line of code. The reason we want to run it instead of maybe stepping over it is because if we started stepping through this code, we'll get into the Java stack traces, such as part of what's inside of JUnit and also what's inside of WebDriver Manager, and we don't want to be looking at that code. So we ran it here, and now we are inside of the smarter test. So you can see this always executed first, and this will execute second now, our test method. And now you're 100% familiar with this code, right? We're creating a new Chromedriver just like before. However, you can see we got rid of the ugly paths. And so now we can just basically execute this, and it will work exactly as before. So I'm going to come here again, click resume program, and it will execute through completion. So I hope you saw that it finished and executed through completion. Now this WebDriver manager provides us many other capabilities, such as, you can see it has many other drivers here, such as Opera or Gecko, Edge driver. You can see so on and so forth. So it can work for all other drivers. And then whenever you want to use those drivers, you would come here and simply replace which driver you want to instantiate. So if you want a new Safari driver, you can have a new Safari driver, and so on and so forth. And that is much easier to do than managing all of those paths that I've shown you before. And I highly recommend this method from this point forward, so you don't have to worry about maintaining your browsers and your drivers. So this line of code here actually allows us to start a new Chromedriver. This is what allows a server, little server to run, which is the Chromedriver server, that then processes our code and allows it to interact with the Chrome browser. Let's continue here. Now we are going to actually go to our application that we are going to test. Let me show you that application. That application is going to be saucedemo.com. It's a very simple demo web app that is an e-commerce store. So we're going to grab this URL and we're going to navigate to that URL. So we're going to do this. Will take us to the actual URL of our website. Next, what we want to do here is add what's known as an annotation. We're going to add test here as our annotation. And as you will see, the compiler will highlight this in red and complain about this. So it gives us some fixes here. The fix that we want is to add a Maven dependency, because this will allow us to use a unit testing framework, which is a framework that allows us to run different kinds of tests, such as our automated Selenium tests. It does running, execution, reporting, gives us test status and all that kind of stuff. Again, code that we will download. So we're going to add a Maven dependency. We're going to search for an artifact. We're going to type in JUnit, and we're going to get JUnit 4. During this recording, JUnit 5 currently does not support parallel test execution at the method level. It's a problem, and so we're continuing to work with JUnit 4. If you're gonna try and use JUnit 5, the API is nice, but the test can't run in parallel on the method level. So be very careful and make sure that your future JUnit version, if you want to go with 5, it does support running in parallel methods. But we're going to use 4 because that is fully featured. So let's go back to our POM XML and show you that we've also imported JUnit. See this dependency here? It automatically imported it for us. How easy was that? Now that we have our test, you can see that these green arrows now pop up here because the IDE understands that we have a test that we can start running. So let's go ahead and click this green arrow button and see what happens. You can see the test is now running. Look, it's pulled up our browser and we got a little notification here from Intellij that says our test has passed. And that was it. That was your very first test. Congratulations, you just did it. You can come here and you can see this is the view that Intellij combined with JUnit provides us. Intellij tells us that we ran a test and this test passed and it ran in 4 seconds and 493 milliseconds. Congratulations, your very first Selenium test has been executed. The only other thing that I want to add here, because we are automation engineers and we're very lazy, is we always want to be killing the driver after our test is done. So I'm going to do that with a driver.quit method, which does exactly as it sounds. It quits the browser after the test has finished executing. Let's go ahead and click this green arrow, run the first test again. And it will be very fast. You'll see it open the browser and close it. See that? And the test has passed successfully. Congratulations. Job well done. You're now an automation engineer. Let's do the same exact thing that we just did with Intellij with Maven. So the very first thing that you want to do is go to your POM XML and make sure that you download this plugin for your Maven. And so you can get the plugin at this URL right here, which I'll of course supply in the course resources. And here is the plugin, and it goes in this section of build plugin management plugins in here. And if you want to build this out instead of copying, you can actually do that. And let me show you how to do that. So we can do build, and then you can see it provides you the build and automatically provide you a closing tag. Then you would do plugin management as such, and then we would do a plugins. You can see I just pushed the tab key and then it filled it out. And then inside of our plugins, we would insert this code that you can get from the Maven repository, which is the global online repository where all of these plugins live. Now, after you have that ready, you will actually be able to execute your test with Maven. The other thing you want to make sure is that your configuration, the source and the target, are set to 11 because this is the Java version that we are using, okay? Now, once you have all of that set, you can run the Maven test command. And it's actually going to do the same thing exactly as Intellij. And you might ask yourself, well, what is the point of doing something with Maven that Intellij can already do? Well, this is actually really powerful because it prepares us for a continuous integration, continuous delivery environment. Many courses and instructors do this very wrong because they don't teach Maven right up front. And so what students actually end up doing is never realizing the correct folder structure to have in order for the code to work with Maven from the beginning. And so if you don't know anything about Maven, you'll just be creating tests, adding classes here and there. And then when you try to introduce Maven, it's not going to work. And Maven is critical for continuous integration and continuous delivery. Why is that? because Maven will actually compile and build all of our source code together and make it work in a pipeline. So look, for example, let's look here. See what Maven is doing? Maven is actually building all of our code here. It's compiling the code in different jar files, which are just executables with all of the code, and then it makes it able to run. Without Maven, you can't do continuous integration because you can't have an Intellij installed on your continuous integration machine. It would be very inefficient and impractical, and I'm not even sure if it's possible to install it there in order to execute tests. So what you do is rather you have Maven that will download all of the dependencies that you need and then execute all of them. And so that's why we use Maven. And so now the best practice is continuously to run the code with Maven. Throughout our test execution, we can do it with Intellij. Intellij will give us some features, but ultimately you always want to be making sure that you can run it with Maven, because if we can do it throughout our lifecycle, we'll be ready for continuous integration and continuous deployment. So now that you've written your very first Selenium test, congratulations by the way, let's go ahead and talk a little bit about what Selenium is, its history, because it's very important to understand it so that we can better use it for our test automation. So Selenium WebDriver was created in 2004 by Jason Huggins at ThoughtWorks. Initially, the very first version of Selenium was just a JavaScript implementation that allowed us to manipulate the browser using JavaScript. It's kind of, if you're familiar with the tool Cypress, it's kind of what Cypress is doing now, something similar. We're just using JavaScript interactions to actually talk to the browser. In version 2 of Selenium, they introduced the JSON wire protocol, which allowed now a WebDriver to make web requests and talk to your browser through web requests using the JSON wire protocol. Version 3 is the current version of Selenium that is about to actually end soon. There weren't many API changes in version 3. Selenium RC code was removed and decoupled from all of the products. And now, pretty soon, we're going to have version 4 coming out. Version 4 of Selenium is currently in beta. You're free to download it and use it, especially in Java. Java has very high standards for backwards compatibility, and so the beta versions should be working just fine with anything that you could have done in Selenium version 3. And it also has W3C support. Now, W3C support means that the Selenium community has actually been working really hard with the browser vendors to make sure that every single browser supports the commands that Selenium will provide. So it basically says that, hey, if you have a method that allows me to click a button, the method should do this. You should also have an actions method that will allow me to hover on an element, for example. And when I use the hover method from Selenium WebDriver, that hover method will work exactly the same across all of the browsers. This is actually an amazing achievement because what it's doing is creating standards for all of the browsers for the entire web, so that anyone trying to automate the browsers has the same exact standard to follow. I have a very important link to show you in regards to this, and that's this URL. Unfortunately, not too many people know about this, but it's actually a very, very important URL, because what this shows is whether each of the driver components, whether each of the interactions with the browser is meeting the current specifications. So, for example, you can take a look here. IE has 99.45% pass rate. That means that there are specifications that are designed for W3C protocol, and IE meets almost all of them. There are only 5 tests that are failing, and once those tests are passing, it means that the expected specifications of IE are being met. Now, what you might also notice here is Safari. Look at Safari down here in terms of the pass rate. This tells us that if you try to automate something on IE versus something on Safari, it is not a guarantee to work. In fact, there's about 17% of tests that are failing. You can see here 159 tests are failing that are expected to work. So what that means is if you're trying to perform a click or potentially a hover or some other special interaction with Safari that is working on IE, it may not work. Safari will cause you the most problems. And whenever you have any cross-browser problems, you should actually come here to investigate, and you can see every single test here and what this test does. So for example, let's take a look at this test right here, which says that it's an alerts test and that it should handle alert on page before unloading. Look at the browsers that are failing. Firefox is failing, and Firefox Nightly is failing. So you can see that Firefox for some reason doesn't support this, and Safari actually doesn't support this, which in yellow means that it is not expected to, but on Firefox, it's a bug that needs to be fixed. So you can come here and figure out, like look here, for example, on Safari, we can see that children finding test link with leading spaces fails on Safari. So if you come across with an issue where you have a link with leading spaces, Safari will not be able to find it, while on every other browser it will. So cross-browser issues can be figured out here, whether it's a bug in the driver or whether it's something else. Now, there are several other individuals that are worth mentioning from the Selenium community because they have such a huge role. Simon Stewart is probably one of the most popular individuals from the Selenium community, and he is the Selenium lead, and he maintains the Java bindings. And here's his Twitter handle. Make sure that you follow him because you will get great information in terms of what's going on with Selenium. He is one of the very first people to know what is going on with Selenium and to even provide the news about what's going on with Selenium. There's also Jim Evans, who is the maintainer of the Selenium C# bindings. And there's also Titus Fortner, who maintains the Selenium Ruby bindings. Titus Fortner is actually my coworker. He is a phenomenal individual. In fact, all of these people are such amazing individuals, and they need to be followed, and we really need to appreciate everything that they have done, because over decades, these people have provided their life to Selenium. They provide their free time. They don't get paid anything, absolutely anything. They do this for the community in support. So make sure you show your support by following all of them on Twitter. And whenever you need any help from them, make sure you say thank you and let them know that we appreciate them because they've put in a lot of free hours to helping our community. And there are actually many other individuals that help the Selenium community. It's not only those three. There are the maintainers of the Python bindings, the JavaScript bindings. There are new individuals that are now entering the project, such as Diego Molina and Christian Broman, who's not directly involved with Selenium, but he has a lot of influence on defining like the W3C specifications and working with browser vendors. And there are dozens and dozens of such individuals that bring the community together and make everything work. And they do it all for the love of the community. They do it all for open source. And it's really a fantastic effort. And all of these individuals deserve the highest praise. So there are actually 4 parts of Selenium, and this is very important. A lot of individuals, especially when getting started, actually mix up the difference between the different parts of Selenium, and so we need to clarify that. There is the Selenium standalone server, there are the Selenium client language libraries, there's the Selenium grid, and there's the Selenium IDE. Now, one thing to note about Selenium IDE is it actually died out for a while. It used to be a Firefox extension, and then at some point the Firefox extension stopped working because of some technical limitations, and the Selenium IDE died. But now actually Dave Hefner and Applitools are working on bringing back Selenium IDE, which is a record and replay tool. Now, for serious test automation, we would never use it, but they are working on making Selenium IDE a better, easier process with much more capabilities and much more user friendliness. So keep your eye out for it, because it could be a good way to play around with Selenium and see what it's doing. So what we're going to be learning in this course is Selenium WebDriver, which is one of the components of the Selenium project. And the Selenium WebDriver is just a language-specific API to implement the WebDriver protocol. It's basically a little package that we download that allows us to send code. The package will interpret that code. It will send the code to our browser and then back, and then that is how it will communicate. And basically this is exactly what it shows right here. Now, the language bindings come in 5 flavors: Java, C#, Python, Ruby, and JavaScript. And this is how they communicate. You have your Selenium code that is written in Java that talks to the Selenium driver that then talks to the browser, and back and forth they go. Like this, the code talking to the driver, talking to the browser, and back and forth this code goes. All right, so let's go ahead and put your knowledge to the test with a little exercise. So I want you to write several tests, okay? First test is you're going to use a different browser to navigate to this URL right here. Now, that depends on which operating system you're on. If you're on a Mac, you can use Safari. If you're on Windows, you can use something like Microsoft Edge for your purposes, just so you don't have to download another browser. So you pick, but of course, all of these tests, you're going to use WebDriver Manager, so that should be extremely easy. Next, you're going to create another test and use any browser you want and navigate to this URL. And then finally, you'll have a third test that will navigate to this URL right here. And all of them, again, using WebDriver Manager. And go ahead and give that a shot. And when you come back, we will discuss it. So let's talk about how you did. So of course, what you're going to need is a before class method, and using WebDriver Manager, depending on the driver that you decide to use, right? If it's Chrome, you're going to set Chrome. If it's Edge, you're going to do Edge, and you're going to set it up, okay? However, if you're using Safari, you are actually very lucky, because now WebDriver by default is built into Safari. That's the beauty of the W3C protocol that I was telling you about later, is that now Safari automatically accepts WebDriver for automation. So what you will find is we actually don't even need this class here, and I'm just going to comment it out. And we're going to go ahead and build and rebuild our project so that everything is cleaned up and we make sure that nothing is left over. And now we can go ahead and run our test. So I'm going to come here and I'm going to click Run Selenium Test. And that's going to go ahead and execute. So you can see here it opened up the first website, and I even put a 3-second sleep in there so that you can see that the websites are actually opening. And you can see it opened up each one. The last one, actually, it opened up the totally wrong URL, which we can quickly fix right now just by copying this and coming down here and putting the right URL. And now let's go ahead and rerun it. Come right here and run. Excellent. Let's even rename this, not to a Heroku test, but shopping cart test. Okay, and here is how the tests look. They all look pretty much the same. Now, I didn't expect you to put this in there. I only put this for demonstration purposes, and so as a result, I was actually forced to throw this interrupted exception. Don't really worry about that. Your test could have looked exactly like this. Look, imagine if I remove this. See how this automatically becomes gray? I can come here and then do Option Enter or Alt Enter and then remove this exception. And so then your test would have looked exactly like this. Okay, again, I just did this for exemplary purposes. So if your tests look like this, you are totally good. And now you know how to do multiple browsers using Selenium WebDriver, and you know how to open multiple URLs. And by the way, as a little bonus, each one of these URLs that I just took you to, they are dummy web applications for test automation. So we can use these to practice different kinds of techniques in test automation, and we'll use some of them throughout this course so that you will better understand how to work with different apps. Okay, thanks. Hey friend, and welcome to the Locating Web Elements with WebDriver section. I am so excited to have you in this section. In here, we will learn one of the most fundamental topics when it comes to UI test automation, and that is actually locating the web elements so that then we can use our Selenium WebDriver to interact with them and perform different kinds of operations. In this section, we're going to learn so many awesome things. We're going to learn what a Selenium script is composed of. We're going to learn how to use Chrome to identify web elements. We're going to learn a little bit about HTML, and then ultimately we're going to learn all of the different Selenium WebDriver locators like ID, XPath, CSS, links, and so on and so forth. This is going to be a really fun section, an extremely critical section, so make sure you got your notes out, make sure you got your keyboard out, because we're gonna do practice, we're gonna have lots of exercises, and we're gonna ultimately have an awesome time. I'm super excited to teach you the rest of the section, so let's go ahead and jump in. Let's talk a little bit about the Selenium script. There are actually 7 actions of a Selenium script. The very first action is instantiating a WebDriver object. Then we navigate to the web page that we want to test. Afterwards, we locate the element on the web page. Next, we ensure that the browser is in the correct state to interact with that element. We perform the action with the element, record the results, and then we quit the test. There are also test runners that we use to execute our Selenium scripts. That's exactly what you've seen previously. Is we used JUnit as our test runner to execute our script. We wrote it and we used this test runner to execute the script. Now, it is highly recommended to use test runners. Maybe a decade or more ago, people used to do different kinds of methodologies, and they actually used to create their own test runners. For example, there was a methodology known as keyword-driven testing. I was actually part of it as well. And what ended up happening in that case was you ended up creating your own kind of executor that would read through something like an Excel spreadsheet or a database, and then would process all of those keywords and transform them and run them and report status and all that kind of stuff. And it was a huge pain. Nowadays, we have these different test runners in the 5 supported Selenium programming bindings that we can use for our test automation. We're going to be using JUnit because that is the one that we prefer. Now, let's talk about each of the steps one by one. The very first step is instantiating the driver. You've already seen this before, but that's exactly this step right here. We decide which driver we want to use, whether it's a Chromedriver or a Firefox driver, Safari, and so on and so forth, and that is the instantiation of the driver. And here you will also see the 7th step to quit the browser, because whenever you start a driver, you always want to quit the browser. It ends the session and it kills the browser instance so that you don't have many browser instances building up on your machine and hogging up your RAM. But it's also really important when we start doing parallelization with like a Selenium grid or a Sauce Labs grid. Driver.quit is a very important method to call. Now, the next step is navigating to the web page. So you can see here that the navigation happens using the driver.get method. We supply the entire URL here, making sure that you're passing in the HTTP or HTTPS. Next, we locate the element that you need to interact with. Here you can see that we are interacting with an element and we're supplying a type of locator. We can pass in different types of locators that we're going to discuss in a little bit, but here we're locating an element by its ID, and the ID's value is called sign in. Next, we want to ensure that the browser is in a correct state and take an action on the element. So how does this happen? This happens with an explicit wait, where we will create a new WebDriver wait class and we will specify the timeout that we want before throwing some kind of an exception. And here we are waiting until some specific condition, in this case for the presence of the located element that we're finding by the ID. And you can see that if it finds this element that doesn't throw an exception, it stores it inside of this variable called sign in, which is now our element. And we can use this element to interact with our application, in which case here, step number 5, we are taking the action on an element. In this case, we are clicking. There are many other actions that we can take. Finally, we just need to record the result. So here you see an example of us using the test watcher. Test watcher, it comes with JUnit, and we can use the test watcher to record the result. So for example, if our test failed, in this case, we are printing out a message saying that it failed. And then if it succeeded, here we're printing out a message saying that it succeeded. Let's do a fun little exercise to make sure that you retained all that information. So I've created a new package here called locating elements, and here we have a locating elements test. Okay, I'm going to enter into full screen view so that it's better for you to see. So now here I have a test. This test is disorganized. If we run it, it will fail right now. Watch. It will fail. See that it failed? And here it's throwing some exception. Your goal is to rearrange this test correctly so that it actually passes. So how are you going to do it? You've already seen almost all of these statements. So your goal is to match the statement, put it in the correct order, and match it with the appropriate comment. I will give you a hint because you've never seen this before. This step right here, this one, actually is 2 steps in one. So we are taking an action on an element, and we are recording the result using assert true. It's doing 2 steps in one right here. That is your hint. This step is correct in terms of the comments. Now you need to order all the other steps around it and put the comment on top to explain exactly what that step is doing. Okay, so that's your challenge. When you come back, I'm going to give you the answer. So let's see how you did. So here is the correct order. Obviously, these comments should be ordered from number 1 to 7. That should have been easy. But then the question is which commands go with them. And this is the correct order. Now, there was one tricky part because finding an element and checking its state were actually 2 steps. So here we are actually finding the element and checking its state by checking that it's present. So that's actually 2 steps in one right here. And then here we are taking action on the element and we are recording the result. So hopefully you got that right. You can check it by running the test, and the test should pass if you got it correct. There's our test, and you can see that it passed successfully. So hopefully you got that right. All right, so in the next several videos, I'm gonna introduce you to HTML basics. Yes, that's right. As automation engineers, you're going to have to learn how to use HTML in order to identify your web elements. The better your understanding of HTML, the easier it will be for you to identify web elements whenever you run into trouble. You'll be able to identify elements that are complicated to identify, or you'll be able to identify elements that are easy to find inside of the HTML. You don't need a huge knowledge about HTML, but you do need some basics that will help you to work with web elements whenever using Selenium WebDriver. And I'm going to provide you those basics. Don't worry, it won't be too much. It will be easy. And once you're done, you will be able to comfortably use HTML in order to identify your web elements. The very first thing you should know about HTML is that there is a thing known as a tag. A tag looks like what you see on the screen right now, and it has a name. And a tag is in between 2 carets, and there's an opening tag and a closing tag. You can see that they look exactly the same. They have the exact same name. However, the closing tag has a /, and that's how you know which is the opening tag and which is the closing tag. In between those 2 tags goes the content. If you're familiar with XML, this is actually very similar to XML. You can see that there's a start and an end tag, and in between goes the content that you want to put related to those tags. A tag may have multiple different names. A tag may be an H1 tag, which in HTML means that it's a header tag. A tag may be an IMG tag, which in HTML means that it is an image. So whenever you have an IMG tag, it means that inside of it lives an image. You may also have an A tag. An A tag is a link inside of an HTML. So as you will notice, all links inside of HTML live inside of A tags. The other very important thing that you need to know are HTML attributes. HTML attributes live inside of the opening tag only. Attributes are basically something that you can add in order to help differentiate the different tags from each other. Also, they may provide different kinds of behaviors to a tag. So in this case, we have an H1 tag and we have an attribute named attribute that is equivalent to some value. And of course, we have a closing tag for the HTML attribute. We may have an image tag, and inside of that, that image tag has an ID, and that ID has an ID value. We may have a link attribute. A link attribute in HTML is known as an href, and that has a property that normally points to a link. So that's how links actually work. They're wrapped inside of an A tag, and then inside of that, they have an href attribute that tells us where to go whenever we click that link. In this tutorial, I'm going to teach you how to use Chrome browser so that you can inspect the HTML of different elements. So there are several ways to do this. One way to do this is to open up the page that you want to interact with and obviously have Chrome browser installed. And then you can click the three little dots here. You can come down to more tools and click developer tools. You can also see the shortcut here for that as well. So if I open up developer tools, it will load up developer tools. And so now I can use this little square with this pointer icon in the left hand side that will allow me to select the elements that I would like to select. So for example, I can click on it, and now if I want to interact with this button, I can go ahead and click on this button and it will automatically highlight it for me in the HTML. Now you can see the HTML here. As I move over the different element tags, it provides me with a view of what that represents in the HTML. So you can see how if I start over here, for example, at this div, I can go down to this div and down. And as you see, it's like a hierarchy, right? You can see I'm going from a wider area to a narrower, and it keeps getting more and more focused until we are at the exact location that we want to see. Makes sense, right? So that's how you can use it to view. A lot of times it's very useful to do this because maybe you want to interact with this element, but it doesn't have the best locators or it doesn't work. You can move up one level and try to interact with something above it. The button is not a good example, but here maybe you want to interact with this element, but it's not good enough. So maybe you can move up to its class and interact with that. And if that doesn't work, maybe you can move a level higher and work with that or with that. So there's many different options. The other feature I wanted to show you while I'm in here in Developer Tools is the Control F feature. So if you hit Control F while in Developer Tools, you'll see this little search bar open up. And in the search bar, it says find by string, selector, or XPath. So you can use CSS, XPath, or strings to locate your element. So for example, let's say I want to find all the links. I can do something like this, and now this will show me all the links. It's found 82 links, and I'm on the first one. Over here in the HTML, I can hover over it. It doesn't actually show up on the UI. And then you can obviously scroll down, and as you can see, it shows you the different links of the page as such. See that? So you can use this to construct your XPath queries that you're going to learn about in a little bit, or your CSS locators, or you can even search for a string, but by, for example, like this. See? Start learning now. So I found the Start Learning Now button. I can even search for string. So that's very useful because we can try out our element locators here before placing them into our C# code for Selenium. And one more pane that I would like to turn your attention to is over here on the right hand side. These are CSS styles for each element. So for example, if I click on this button, these are the CSS styles for this button. We can use this using Selenium WebDriver. We'll be able to use by the get CSS locator using these properties. For example, the color, the background, border width, font size, or any of that. If we select a different element, we'll have different properties, as you can see, and we can use these to do different kinds of verifications as well. So that's that. The other thing that I quickly wanted to show you is just a shortcut for opening Developer Tools. You saw the Control-Shift-I, but you can also do F12 to open up Developer Tools. See that? F12 opens it up, and then all you have to do is use the little picker and then select your element. And then a third way to actually open up Developer Tools is you can come to an element, right-click, say Inspect, and that will also open up Developer Tools and automatically put you on the element in the HTML source code. So that's it. So that's how you can identify elements in Chrome. And as we proceed, make sure that you use Chrome to help you with element identification. See you in the next video. Here's a great idea. Why don't we actually look at some HTML and see exactly what I was just talking about. So open up your Chrome browser and go ahead and navigate to this URL right here. And if we want to open up our developer tools, we can look at some elements. Like, let's look at this button, for example. As you can see, this button is actually, we're hovering, as you can see, we're hovering over a link inside of a button. So that's number one. And as you can see, this link is an A tag, as we've specified. This link has a class attribute that is set to this value. This link also has an href attribute that is set to this value right here, slash button success. And this link also has an ID attribute that is set to ID example. You can see that our A tag starts here and ends right here. So as you can see, it can be multiple lines as long as you have a closing tag. This is the opening tag, this is the closing tag. Remember, all attributes only go inside of the opening tag. You'll never find attributes inside of the closing tag. If we go up a level, you can see that we have a button. A button has a tag called div. In fact, majority of our elements here are divs. So if we actually open this up and come right here and I do div, what you will find, actually, let me do like that. So this locates all divs on the page, all div tags. You can see we have 179 div tags on this page. Over here, if I hover over this element, what you can see is it actually an H3. H3 in HTML means it's a header tag, but this one is lower than an H1. Somewhere here, there should be an H1 tag. And actually, there isn't an H1 tag on this entire page, but the H1 tag is a header. All H tags are headers. So in HTML, as you can see, tags have some specific meaning, and that allows the HTML to function based on that appropriate tag. And then, of course, you can set attributes depending on what you need. In this case, the attributes tell which kind of class it is, and so then the HTML elements functions appropriately. And IDs and other types of attributes, they can all be utilized in order to help us identify web elements. We can use all of these kinds of different attributes to help us with web element identification. I wanted to show you another cool little trick that you can do using Chrome developer tools and work with HTML elements. If you actually go to this URL that I have up here and then open up your developer tools, you'll be able to work with, say, this element, for example, and any element inside of our HTML, we can go ahead and right click it, and then we can come over here to copy and say copy element. So then if I paste that in somewhere like a notepad, you can see that it's copied the entire HTML tag as well as all of the attributes for me to work with that information. We can do other stuff as well. You can right click, do copy, and you can copy outer HTML. So if I come back to our notepad, I can come here and paste. That's the outer HTML in this case, because there's no inner element inside of this. We can go back here. We can come here, do copy, and copy selector. So this will provide us a selector to use for this element. So there's the selector to use for this element. This is actually a CSS selector, and this is the absolute path to the CSS selector. This is actually a horrible way to identify an element. I'll talk about that in a second, because we will also be able to copy an XPath selector, not only CSS selector, but an XPath selector. And so then if I come and paste that here, you'll see a full XPath selector as well. This is an absolute XPath, and this is absolute CSS. Both are horrible ways of identifying elements unless they are actually unique. The problem with this location strategy is that it identifies every single element in the chain in order to get there. So let me copy this selector right here, and I'll show you exactly what I mean. So if we use our Command F or Control F if you are on Windows to open up this search, and I'm going to paste that in here, you can see that it identified this locator, right? But what it did is it actually used an absolute path to get here. So, for example, what if instead of this div, you know, our elements get moved around? What if we add a new element? And so now our div, instead of being at location 2, is at location 3. You see that now I cannot find that element any longer. It is only valid if we are at location 2 with that div, or if, you know, this div, there was in another section, another div got added or removed, you can see that our element can no longer be found. So this you can think of maybe someone living in an address, right? And you have the person's address, but you don't exactly know who that person is living in that address. You just know that you have the address and you need to get there in order to get to a birthday party. And you may get there and that person may be there for the right birthday party. Or you may get there and the person might have moved. And so now, although you have the exact address, you still can't locate the person because you don't have their phone number. And that's why absolute XPaths and absolute CSS paths are bad. Instead, what you need is known as a relative XPath or a relative CSS path, which will represent a person's phone number, so that regardless of where the person lives, you can always call them, get their new address or old address, and then get to their exact location based on the address that they provided for you. And don't worry, we'll cover relative XPaths and CSS paths in a bit. I just wanted to show you this and explain to you the couple tricks that there are in Chrome Developer Tools. Okay, it's about time we do a little exercise, don't you think? So, the exercise that we're going to do is you're going to navigate to this URL right here, saucedemo.com, and I want you to open Developer Tools and Inspect mode, and I want you to identify for me the tag name and one attribute and its value for these elements right here. For element 1, for this element 2, this element 3, this bot 4, and this Swag Labs icon 5. I want you to identify the tag name and one attribute and that attribute's value. You can just write that down on a piece of paper for those 5 elements. When you come back, we'll talk about the answer. So let's talk about the answer. So right click and inspect to open up Developer Tools, and then we can grab this little element picker and start hovering over here. So look, right away you can see that this whole thing is a form, and this element's tag is input right here. It's an input tag, and it has many different attributes, such as a type attribute with the text value, such as a class attribute with a form input. You can see it has even an ID called user-name. Let's go to the next one. The next one you can also see is an input, and it also has an ID with a value password. Next, let's look at our login button. So we can come here and we can look at the login button. You can see the login is also an input tag, and then it has this class called btn_action. Let's keep looking here. Next, we have this bot. So the bot, it lives inside of a div, and it only has one attribute, which is called class, and the value is bot_column. Finally, let's take a look at the Swag Labs icon. So this whole thing right here is the login. Sorry, it's a div, which is the tag name, and that has a class with the value login logo. Makes sense? And so that's it. You can see that this is the whole thing that holds that login logo. So hopefully that was pretty easy. See you in the next video. So, okay, enough talk about HTML. Let's actually talk about how this applies to Selenium, right? Which is the whole reason why we're here. So in Selenium, there are 8 types of locators that you can use to find elements so that you can interact with them. There are the ID, name, CSS, class name, tag name, link text, partial link text, and XPath. Here are some examples of how it would look in code. So we always use the by class. This is the class that's provided to us by Selenium. And then we can select options such as ID, name, class name, tag name, CSS selector, XPath, link, and partial link text, supplying the appropriate value for that selector in quotes. Let's go take a look at some actual code. Okay, so let's take a look at our sample application. Here I have it pulled up. I have developer tools open, and we are going to select an element, and I want to analyze this element right here, our user name, okay? And so I'm gonna show you exactly how to write the code so that we can identify this element, okay? So very first thing I want you to note is this ID, okay? I'm gonna grab this ID and we're gonna use it. IDs are one of the best locator values to use for element identification because they are always unique. So let's go back to our code and I'm gonna show you exactly what we're gonna do. So here you see I have a test called types of locators in the same class that we were using before. Everything is exactly as you have seen it before. Here I'm navigating to our URL. Here I set a variable called element, and now we're going to use that element, okay? So we're going to do element equals, and we're going to do driver dot find element. See how I can use my IDE to help guide the process of typing everything out. And so now at this point, actually, I can just hit the tab key and see how it filled in the rest. I'm going to use the by class. See how my IDE is telling me to use the by class. So I'm going to use capital B by. That's a class. We're going to do by dot. And now look at all the locators that we have available here. You see all of these? And so I'm going to pick ID because that's what we want. I want to show you first. We're going to put quotes, and then I'm going to put the ID in a string as such. Let's try the next one. And actually, we don't even need to be setting the element. This call right here will actually store the element into a variable called element. And so if we wanted to perform some operation with it, we can now perform an operation with it. However, this call right here will just try to locate that element. And if it does locate it, it will store it in a variable. If it doesn't locate it, it will throw a no such element exception. Let's try the name field as well. Okay, so let's go take a look at our application. Our name field. This does not actually have a name field. This element does not have a name field. But if it did, it would just have an attribute that looked something like this. Let me show you a cool little trick here. You can actually come here. It would just be something like this. Name equals username. Does that make sense? And so then you could use that locator. Let me show you how to do that in code. So again, driver dot find element. I'm pushing tab key by name, and then we would just pass in the name as such. Okay, this will not exist, and so it will fail. So I'm going to comment this one out. I don't want my test to fail. Now, class name, tag name, CSS selector, XPath, link text, and partial link text. Let's talk about those. Class name, you can see the class name is right here. Okay? So I want you to write out the code and type that in for class name. For tag name, what is the tag of this element? We just talked about it. You should know it. I'm not even going to tell you. You should be able to find an element by its tag name. And so you come here and fill in the tag name. Now the CSS selector, this is a little bit different, and we're going to talk about CSS selectors and XPath selectors. They are very unique because they are extremely dynamic in helping us to locate elements. These are actually, but if I don't have IDs available, I am usually using CSS or XPath selectors that are very good CSS or XPath selectors to find my elements. Now, CSS selector can be anything. You can use the tag name combined with another attribute, for example, or we can use a class name inside of it. We can use this data test tag. We can use an ID. CSS has its own special syntax. We're going to talk about it in a moment because it deserves a whole lecture of its own. But in the meantime, I'll show you how we can, for example, grab a CSS selector. And so I'll copy here, and we can say copy selector. And so then when we come here, this shows me the selector. Look, this is CSS special syntax. It's picking based on an ID, but in CSS you pick an ID using hashtag. Again, we'll jump into that in a second. So knowing what you know, I will tell you that this is the string that you want to pass in to your CSS selector. Write me the correct line of code that will use by CSS selector and passing the correct string, which is this string, okay? XPath will be exactly the same thing, but it also has its own syntax. Let's take a look at that syntax. So come here, copy, and we can copy XPath. Let's paste the XPath right here for you. And so you can see actually XPath brought in these two forward lines as well. Exactly the same thing as a comment. Don't worry, this is not a mistake. This is actually the syntax of XPath. So this right here is the exact string that you want to pass in to the by.xpath locator. So what I want you to do is use driver find element by XPath and pass in the correct string. Link text. Link text we cannot apply to the username field because we don't have a link here. Let's check if our login button might have a link inside of it. Our login button also does not have a link inside of it, and maybe our Swag Labs has a link inside of it. No, none of these have a link inside of it. So I will need to provide you an example. Let's go find an example of a link. So for the links, I want you to come to this URL here that will also be in your course resources. And I want you to click this link right here, using link text. And I also want you to click it using partial link text, which is just a simple partial link text like this, or like this, for example. You pick which one you want to use. Just make sure that it's unique. And so if you click this one with link text, you can see that this one will actually be unique because this is the only one that has an exclamation point at the end. So I would actually recommend you put this as your partial link text string. And of course, don't forget to quit the driver at the end of each of your sessions. Now, let's go ahead and do that exercise. And when you come back, I'll show you the answer. So hopefully that wasn't too hard for you. let's go and check your solution. So the very first thing I want to do is actually run this test and make sure that it passes, because if it doesn't throw any exception, then we know that our test was successful. So it ran, and then the other window popped up in another laptop of mine. So you can see that the test passed here. So everything was successful. And here is the solution. So again, it should have been pretty straightforward, but we have our ID, class name, tag name, CSS selector, XPath, and then we quit the driver. And then of course, because we needed to navigate to a totally separate URL, we wanted to start up a new driver. We could have also actually gone to a different URL without doing all of this. However, I was silly and I can't do multiple things at the same time, so it's hard for me to talk and code as well. So I just made a coding mistake, but we could have just bypassed all of this nonsense and could have just gone to the URL directly. No big deal. The exercise here was identifying elements. So then here is how we use the link text, and here is how we used partial link text, and of course quitting the driver all at the end. So that is how you use every single locator in Selenium WebDriver to be able to identify elements. Now, one other quick thing I wanted to show you was that if for whatever reason you don't supply, the locator doesn't work, right? Let's pretend here that we add this to our locator. Let's run this test and see exactly what happens. Obviously, this locator doesn't exist because I just made it up. And so when our test runs, it's going to try to look for the element. And number one, you see we got a test failed exception. But when we go and look at the test, it's very important to analyze the exception that we got. So I come here, all of this text here is just information. What's really important here is this exception right here. So look, this says no such element exception coming from openqa.selenium. This is the exception that we get when an element is not found because A, our locator is not good, or B, the element actually doesn't exist on the page as a result of possibly a synchronization issue, or possibly because the element simply just is not there. However, it's very important to see this error and realize what happens. And then it's important to read further into it. Unable to locate element, method CSS selector, and here's the selector we used. And so this can actually provide you some information about what's going on. Now, assuming we know our application, which we do know a little bit, right? We can look at this selector and see, oh, whoa, hashtag username, name, FIFIF. That is very weird, right? That might be a mistake. And so then we can go in and change it. But if we don't think it's a mistake, then we have to go in and debug it. Now, you don't have to debug it now. I just wanted to share this with you because all too many common times I have customers, I have students coming to me with this error, and all it is just an element not found error. And so it's just a matter of making sure that the element exists on a page or that you're using the valid selector. So I'm going to get rid of this again, and hope you did okay there. Let's go, see you in the next lecture. Now, because we are test automation engineers and we are really awesome at automating stuff, I wanted to make the process a little bit easier for you and show you some very cool tricks on how to make our code not only cleaner, but with also less duplication and more automation. Doesn't that sound awesome? So what I did here is I created a new method that is called a setup method. This method does what our code used to do before. Remember that our code used to set this property and set this driver over here in Elements Quiz 1 and also over here in types of locators. So look, I can actually get rid of it, which is exactly what I'm going to do, and everything still compiles and there are no problems. The magic about this method is that we are using Intellij. We're using the Intellij before annotation that tells Intellij that before every single test method is executed, I want you to execute this test method. And so whatever's the logic is in here, it will run before every single test method. Let's give this a run so that you can see how it works. And actually, I will step through it so that you better understand. So let's go ahead and debug this code, and I'll show you exactly what it does. One other thing I wanted to mention as well is notice how I put this WebDriver at the class level. Before, it used to exist inside each of our methods, so only our methods could use it because it was in the scope of those methods. Now our WebDriver is at the class level, so all of our test methods can actually use the driver variable without having to instantiate it inside each of the methods. So let's go ahead and throw a breakpoint here. And what I want you to pay attention to is how this code is going to get executed before we get to this breakpoint, because it's going to run before every single test method. So I'm going to click here and I'm going to say debug. So in a moment, boom, there's our Chromedriver. See, our Chromedriver, and we didn't even get to this line of code. We are now stopped at this line of code, and we see this debug window below. Over here in the debug window, we have a lot of very useful stuff, like these variables here that we can expand and analyze. And we have the stack trace here as well. We also have these commands that we can use to step over our code. So I'm going to step over this WebDriver.get, and it's going to navigate us to the URL. I'm going to come over here. See, we're over here at the URL. I'm going to step over this WebDriver wait class, which doesn't do anything except actually just create a new wait class. And so you can see now we have a new wait variable that holds an instance of the WebDriver wait class. And now we're going to wait until this element is present. And I'm going to step over that as well. And that's going to return our element. Give it a second. There it is. And so now if that worked, we should have an element. You see we have an element here. And if we expand it, we have a bunch of different properties related to that element. And so as I run this right here by resuming the program, you'll see the test finish successfully, even though we removed that extra code duplication. So you can see the test is done, and you can see that it is successful with this check mark. So that is the beauty of removing that duplication. Let me show you another very cool trick and way to remove even more duplication. So a lot of people don't know this command in Intellij, but it is extremely powerful. Using Control-N, you can automatically get Intellij to create code for you. So I did Control-N, and now look where I'm going to go. I'm going to go to a teardown method. And so I'm going to hit enter right here, and it's going to populate me a brand new teardown method. Look, how cool is that? And so what I can do in this teardown method is remove all the logic that we keep repeating right here, which is quitting the driver. So I'm going to take this code out, and I'm going to paste it in here. And I'm also going to remove this because you can see our IntelliSense tells us, if we click, look, remove exception from teardown throw list because it's unnecessary. That's why it is grayed out. And so we can actually use the option enter key and then hit enter to remove it. And it's that easy. That's the power of a beautiful Intellij. So I'm going to remove it from here, and I'm also going to remove the code from here as well because we don't need it here at the end. And so with that, everything should be successful, and even without this. And I'm going to actually remove all of this extra code here as well because we don't need to quit the driver after. We don't even need to find the new. Rather, we just navigate to a brand new URL. And so now we have just removed the driver.quit method by using an after annotation. After annotation will do the opposite of a before annotation. It will execute after every single test method. And so which code is going to execute after every single test method? The code that we put inside of this test method. That's how powerful it is. So now we can test to see whether this works by scrolling up here, clicking this button and clicking run locating elements test, and it will run all the tests inside of this class, which we currently have 2. Oh, and of course we have to stop and rerun because I was running something else. So here you'll see it will open up the first test. And then it switched to the second one, did the second one. Let's see what else is going on. And 2 tests passed. Fantastic. And 2 tests passed. You can see that both of them passed successfully. So everything worked, and we just removed the extra duplication. Take a look here, okay? So from this point forward, I'm going to be using before and after annotations, also known as hooks, to make our tests cleaner. We're no longer going to instantiate drivers and quit drivers, but it's always going to exist, and I'm just going to move this code from test to test, and you just know that it's there running in the background, saving us from extra work. In this tutorial, I want to cover XPath. XPath is going to become your best friend when it comes to locating web elements, because it's not always going to be as easy as I've told you to use all of those Selenium locators like ID, class, name. So XPath is going to be one of your strongest ways of locating any element anytime. Doesn't matter what's going on in the HTML. As long as you can get creative, you'll be able to come up with a good XPath strategy to help you locate an element. Now, XPath has several important expressions that you definitely should know. First is the /. The / basically selects from the root node. Now, just remember these definitions. I'm going to show you all of this inside of the browser, all of these examples so that you better understand them. But in the meantime, just remember the definition of each item and what it does. The next element is a /. The // selects nodes in the current document that match the selection, no matter where they are. Now, the root node can only select from the next level, and the // can select an element no matter where it is. You'll see this is one of our most commonly used XPath expressions is the //. Next, there's the period. The period just selects the current node. To be honest, this is one of the least used XPath expressions, the period, and we won't need to utilize it much. I almost never utilize it. I just wanted to make you aware that it does exist. Next is the double period, which selects the parent of the current node. This one is pretty useful and will allow you to select the parent. Finally, we have the @ symbol, which allows you to select attributes. So once you've located some tag or some node inside of the HTML, now you can select an attribute. More XPath expressions. There's also a *, one of my favorite XPath expressions that you can use that will allow you to match any element node. You'll see we use the * a lot as well. // we already talked about. Now, let's go ahead and move on to the actual application so that we can see all of these in practice. So here we are at our automation practice page. Make sure you navigate to this URL. And before I proceed, I also wanted to make you aware of this special resource from Automate the Planet by Anton Angelov. He's one of another C# Selenium gurus that I like to follow. And he has this Selenium WebDriver Locators cheat sheet that will help you with any kind of expression that you need. Not only does it have XPath, it also has CSS locators that you can use in order to handle different kind of location strategies for Selenium. So just wanted to make you aware of it. I recommend you save this URL so that you can refer to this in the future. I didn't want to recreate it because why recreate something that already exists and is great? So anyway, back to our application, and let's go ahead and analyze this clickable icon. So let me scroll down a bit so that we can see it. And so now, what XPath really allows you to do is to locate elements by traversing the HTML, as opposed to using something, like an ID or a class name or something like that. You can traverse the HTML and kind of think of it as step-by-step directions from your current location to where you want to get to. It's like Google Maps or Waze navigation that takes you exactly where you want to go. So for example, our HTML starts with this HTML tag. So if I type in /HTML, //HTML, it will take us here. So we've began traversing our HTML starting at the very top element. Now, if we want to get to the next element, we can use a /. Remember, that allows us to get to the next element. So the /, if we want to get to the head element, we can do it like that. And there are actually 2 head elements in here, but if we wanted to get to this one, we do it like that. Now, if we wanted to get inside of the head elements, so let me uncollapse it. If we want to open it up and get to the meta tag using a /, that will be impossible. That's the limitation of the /, is you can only directly navigate to the next element. So inside of the head, if you want to get inside of there, if you want to get to the head and then get to the meta, you have to directly do it like this. There you go. See that? Now you can only directly traverse inside of that. And then if meta had another tag, you could directly get inside of there. So here, script has a var tag. So we can do script. And now we can do script /var. But that won't work because did you see which script it identified? It identified this first script. So if you directly wanted to get to the script tag without traversing through the head tag, all you have to do is delete the head tag and use the double / that will allow you to navigate directly to the tag without having to navigate its children. So in fact, I can even remove the HTML and it will still work, as you see that. And so now if I want to get somewhere like our clickable icon, which is an A, what I can do is 2 / A, and that will take me to the first link. It didn't take me to the link that I want, but it took me to the first link. Okay? So that is the difference between a / and a double /. A double / is way easier to start navigation and get exactly to where we want to go. So for example, although there are many links here, maybe I can navigate to this H4 and maybe that will help me to get closer to my element. And as you see, it kind of gets close, but not close enough. I still have to traverse many H4 elements. And so it cuts the majority. Look, it saved me from navigating through all of these tags that I would have had to traverse in order to get to my element. And so that's what the double / does. Let's continue talking about the @ symbol. It's very powerful. Again, it allows you to select any attribute. If I wanted, for example, to select a form, well, actually, this form doesn't have any identification. I could select this. You already saw class. I'm looking for an element that has something unique, like, Oh, here we have with a name. So let's look at this button with a name button 1. So all you have to do is update this locator, this attribute, and call it button 1. Boom. And we've directly selected the exact element that we would like. Also, you can see that there are elements with an attribute called type submit. We could try that and see what that looks like. See that? It's selected 10 elements. You can see that right there. The reason it selected 10 elements is because there are 10 elements with attribute type equals submit. So in this case, it is not unique. But you can see the power of using the @ symbol is that it can help you to directly manipulate elements that you want. Now, with that said, what if we wanted to navigate somewhere else? So in that case, we can do a / and move up to the parent. You can see that that's what the double dot did, the double period. It moves up to the parent. And so now we can actually traverse the HTML in this way by moving up. And so the benefit of that is, let's say that your unique locator is this one, right? This one has an ID, and so we can utilize this button. However, this does not, right? Yes, it has action. Here, we can try it. It has this action. Let me copy that URL. I can type it in. So at action, ultimateqa.com, and let's remove that. Right? So you can see there are actually 2 such elements that have this exact action. So if I wanted a unique one, if I wanted this exact one, I would have to use this element as a starting point. So we can do @ID. Button 1. Perfect. Got my starting element. And now I can do its parent. Boom. There we go. I've got the element that I would like to interact with. Although there's no point in interacting with a form, it's not going to do anything. But just for exemplary purposes, you can see that this is why you would use a double dot. Let me share another powerful XPath expression that I really love and that you should learn to love as well. So let's take a look at this button and this button, okay? Here I have hovered over this button. You can see it has an ID, button 1, it's submit, and it has this text. Now, the next button, what you can see is actually exactly the same. The only thing that differs is the text that is on top of the button. So how would we interact with these buttons? They're exactly the same. They even have the same ID, which is bad practice on my end, but for exemplary purposes, it has to be there. So how do we interact with them? They're the same exact element, just with different texts. Well, that is this very powerful expression right here, which is contains text. And so now we can type in the text of the button that we want. In this case, it will be XPath button 1. So let me place that in here. And check it out. So now I use this XPath expression, which provides me 2 functions. A contains function, and a contains function, you open a parentheses and close a parentheses, and then a text function, again, open, close parentheses, put a comma, and inside of single quotes, I paste XPath button 1, which is the text inside of the button, and that allows me to locate a button that contains this text. Now there actually looks like 3 of them. Yep, there are 3 of them, which is okay because I've named them all the same, but you can see that it will provide me a button with the text that I want. If I wanted XPath button 2, all I have to do is update this string right here, and now this has provided me the only XPath 2 button that is on the page. See, that is a very powerful expression that you can use to capture whenever you need to work with text. Because again, as you see, all the locators are exactly the same. Even the parent is exactly the same for these elements. You can see that here, parent, parent, but the only thing differentiating them is the text. And so you can use this expression to help you locate elements. Let's talk about a couple more cool XPath expressions that are also available here, which you can do something like a parent or a following sibling or preceding sibling. So a parent of this element is an element directly above it. So you can see that this is the child of this element. Siblings are elements that are on the same level as each other. So for example, if I collapse this and collapse this one, you can see this one, and this one, they're all siblings. You can see that they're siblings because they're on the same level. In that, if I expand this, this has children, but this one is on the same level as that one, right? Makes sense, just on the same level in the HTML. So these are all siblings, and above all of them is their parent, which is this guy. If you want to identify the parent of this class right here, you can see that I've used this XPath right here. I've supplied the class name, and then I did /parent, two colons. Sorry about that, I totally messed that up. Parent, 2 colons, followed by a div. That will identify the div that is related to this child. Now, maybe if I wanted the parent called article, I can come here and do article, and that will not work because you need the direct parent of this element, okay? So, I mean, it's pretty much the same as a double dot in this case. You can also find the element like that, see that? But just another means of identifying an element. And then, as I mentioned, you can do the same thing with following siblings or preceding siblings or any kind of locator like that. You can anchor yourself into a unique element and then based on that navigate up or down in the HTML based on what you need. Also, while we're here, I want to cover another very important thing in that there are what's known as compound class names in HTML. That's this example right here. As you can see, this compound class name is 2 strings put together. So let me unhighlight it so that we can better see. Actually, you can see in here that there is a space in here. And if you try to do by.className inside of Selenium, it will not work. And the only way to work with compound class names, which are now very common in HTML, is to use an XPath expression, because compound class names are not allowed inside of Selenium. And so whenever you have this kind of situation where you have spaces inside of the class name, you have to use XPath. Okay, that's a very important thing, because you're going to come in here and you're going to try to use these class names, but they're going to trip you up because they're compound. Now, I quickly just wanted to share a couple more pieces of information before proceeding to the next topics. So, if you wanted to identify an element by using multiple attributes, what you can do is actually write code that looks like this. So in this case, we're actually looking at a type called submit and a class of button class, in which case that narrows it down to a single button that is right here. If we remove this, what happens is we actually get 10 elements back. And so if you wanted to narrow down the 10 elements, we narrow them down by adding another property, another attribute that looks as such. And so then that gets us the element that we exactly desire. Of course, we could have just used this from the start because this is unique. However, as an example, I just wanted to show you how you can narrow down using multiple attributes for the same tag. Okay, so see how this tag has 2 attributes? You can use those 2 attributes for the same tag. And with that said, if we have 10 elements coming back with this kind of search, right, there might be a situation where your elements are not unique and you have nothing unique to use, in which case you can use an attribute or a tag name and get back all the elements and then pick that element from a collection. Remember that this is going to come back as a collection, so you can use the find elements method, and then the find elements method is going to return you a collection that you can use an index of and then just narrow down to the element that you want using the index. You can do that in Selenium WebDriver. Just wanted to make you aware of that, so if you ever encounter that situation, you can do it. It shouldn't happen too often, but sometimes it will happen. And when it does, now you will know how to handle it. There is one other type of selector that's worth mentioning, and that is the CSS selector. CSS selector is just similar to XPath. It's another way for us to have very flexible ways to find elements. Here are some examples. So you're always going to use the by.css selector method from Selenium WebDriver. However, you're going to use a different syntax for specifying different values in here. So for example, using a hashtag tells the CSS selector that it's an ID. A hashtag is equivalent to doing a by.id. Here, for example, we're finding an element called input with class form input. Here is an example of us finding a direct child. The element form will have a direct child called input. And here is an example of us using attributes, right? This is the same thing as using XPath, for example, where rather instead of doing the @ symbol, ID equals something, here we're just doing input, square brackets, ID equals username, and you can use single quotes like this. It won't cause you problems whenever you're pasting that into your IDE. So there are huge debates about CSS versus XPath, which one you should use, when and why. Some of them are valid, some of them are not. Ultimately, it kind of depends up to you. If you're doing web automation, then it doesn't really matter. XPath is nice because it can traverse the entire DOM up and down. It's nice because you have the capability to locate elements by text. Sometimes I really like that option, and it's more computer readable. CSS is nice because it can traverse elements from the DOM to the parent to child node and from left to right of the DOM. It's more human readable, and it's better understood by front-end developers because front-end developers use CSS whenever they're designing the web applications. Now, CSS is really good for mobile automation. So if you ever end up doing mobile automation, CSS is really good there, and XPath is actually very slow when compared to something like CSS, for example, especially in iOS, because iOS actually doesn't have an XML map, so it has to be created by Appium, but that's a whole other huge topic that we don't want to get into right now. So what do I recommend for you? Use both of them. Sometimes you use XPath, sometimes you use CSS. It's up to you. You'll see many people using CSS, especially in the JavaScript community. It's very common for people to use CSS there. So if you're familiar with it, it's very easy for you to understand what the code is doing. Other people like to use XPath. You can use XPath as well, and I use it all the time. Now, what I especially want to discourage you from is using absolute XPath and absolute CSS. That's highly discouraged all the time, no matter where. It's unfortunate that I still work with customers and other automation engineers that still use absolute XPaths and absolute CSS. We never ever want to do that. We want to always find the unique identifier without providing too much information, so that our identifier is unique and not brittle, so that when it changes, it doesn't break our test application. Now that you're familiar with all of the different location strategies, let's talk about which ones are actually the best. Because that's right, you shouldn't use all of the location strategies. Sometimes you may want to use one, but there are actually the best practices for using these location strategies to make sure that your code is as stable as possible, to make sure that whenever things change in your application, that you don't have to update your locators, because that's one of the other biggest problems in Selenium WebDriver or any UI automation is locator identification. You'll notice that you'll spend a lot of time identifying locators and making sure that they are unique enough so that when your application changes, you don't have to update those locators, because you will have a lot of locators, right? You get a locator for every single element that you want to interact with. And if you're working at a job for any significant amount of time, your locator repository is going to grow to be pretty large. So the most important locator to use whenever you can is an ID. An ID is the best locator to use whenever you want to deal with an element, because an ID will always be unique. That's why if I come here and I check for this ID example, you can see that there is only a single match on the entire page, and it will always refer to this element. So use IDs whenever possible. Now, I know that some people don't put IDs on their HTML. Yes, there are some developers that don't do that. However, that's not a problem for you as an automation engineer. I recommend that if you don't have IDs on the elements that you want to interact with, you go to the developers and you just ask them to add an ID to their HTML. It's super easy. All they have to do is literally type in these two strings, ID equals, and provided a string value, and then that is it. I've never in my entire career had a developer say, no, I'm not going to provide you an ID for a web element. That just simply doesn't happen. And I've worked with some pretty mean developers, and even they were willing to help out and add an ID. So if you don't have an ID, just go ahead and ask your developers for one, and they would be fine and happy to provide you one, as long as you tell them, that it's for automation and it's going to help make your test automation more stable. Now, another locator you might want to use, although it's not as good as an ID, is a class. So let's take a look here. Here's an example of a class, and here's an example of a class. Let's grab this one. So this one actually will not work because it's a long string. So here you can see, for example, class works, and class identifies a single element. However, there are instances where class may not be unique. And so that might throw you off. So class is an okay one to use. Just make sure you check your application to see if class identifies only a single element, and if it does, go ahead and use it. You could also use name if it is supplied for an element. If it's supplied for an element, then you can go ahead and use name. It's not very common. Well, actually, you can see here that, oh, never mind, here's an ID. Let's say keep looking. Here's a name. There's an ID, IDs. That was my fault in coding the application. I've created too many IDs with button 1, but name in this case is unique. As you saw, I only have one button with name button 1, and so that would work out. And again, double check in your application to make sure that its name is a single unique instance. And you see how I'm doing that here. And as soon as we learn XPath strategies, you'll be able to directly figure out if there's only a single element without having to use, the search feature and looking here, but it is a very easy way to start looking. Now, along with the strategies that you should use, let's talk about the strategies that you should not use. Now, one of the worst things that you can do is use something like this, where you come here, do copy, and copy XPath or CSS. Remember, I told you this is an absolute XPath right here. This is the worst way to do it, although this does have an ID in it because I got lucky and picked the appropriate element. Now, this XPath is the worst because it's absolute. So what that means is, as I showed you before, if anything in here changes, because as you can see, it just uses tag names to directly get to the address, then you're going to be messed up. If we add any element along the way, and now this div is no longer div1 but simply div2, now you are no longer locating the correct element. And so that's something that you never want to do. There is no excuse for ever doing that. And as soon as we learn XPath in the next section, then you're going to understand how you can use this kind of XPath and make it unique enough so that it's not absolute but relative, and at least is stable enough so that an addition of new elements will not throw off your XPath. With that said as well, you probably already understand that you should not be using tag names to identify elements, right? As I've showed you before, if I do this, oh, not div, but div, you can see that there are 153 divs. If you want to try with something like an h3 tag, you can see that there are 3 h3 tags. If you want to try a link, here's an a tag. You can see that there are many elements with these kind of tags. So tag names is another thing that you should not be using. I don't think I've ever used a tag name to identify an element, and there's no reason to, because you'll be able to do it in other means, especially XPath, which I'll show you next. Now, there is one other way of locating elements that I want to tell you about. Most people actually don't know about it. Most automation engineers don't actually know about it, but it's probably the best and most reliable way to have locators added to our elements, and that's using data attributes. So here you can see I'm hovering over our username field, and this has this data-test attribute. Actually, we added that to our application. Now, all of this stuff here may have been added by, the programming language as we're writing up the application, but this data test attribute, we added it uniquely so that we can call this field whatever we want, and it's unique to this field. And so what you'll also notice is there will be other fields with these data test attributes. Like here's the password field. See, it has this data test attribute. And so we can use these data test attributes to identify our elements. This is actually something the developer needs to add extra, which is really good, because then whenever they modify these fields, they just need to leave the data test attributes alone, and they recognize that this will only be used for test automation and testing purposes, and we can always just search for a data test attribute on all of our applications with a specific value. Now, this of course can be named whatever you want. I just recommend you just do something like this, data-test, something, keep it simple. Go to your developer, ask them to throw on a data attribute if they can. So this button doesn't have it, but we should add it. If we could, we'd come here and add a data test attribute. Maybe I need to do that in the future, but we can just ask them for it and let them know that it's for automation. Keep in mind that we don't have to have a data test attribute for every single element. Only request it when you need it. Whenever we're interacting with our applications, that's when we should request it. And just make it part of a good process for developers whenever they're coding to actually provide us with this information so that our application is more testable and we can all succeed together as a team. All right, so let's go ahead and put your skills to the test with a final exam and Make sure that you've attained all the information that I've been teaching you. So we're going to do a very fun exercise, and we're actually going to do a little end-to-end flow here. So what is the end-to-end flow going to be like? Well, you're going to start out here at saucedemo.com, and we're going to sign in, we're going to click the login button, which will then take us here, at which point we'll add a product to a cart, we'll go inside of the cart, we'll click the checkout button, we'll fill out this information like this, we'll click the continue button, and then we'll click the finish button, and then we will see this checkout confirmation page that will tell us that we have successfully completed a transaction. Now let's take a look at the code and what you have to do. So I've written this code here, and you actually need to copy it line for line. I actually want you on the keyboard practicing writing out all of this code, okay, here line by line. Now the challenge will come into right here. Here's what I want you to do. So for the very first page, I want you finding elements only by CSS selector. So you're going to supply the correct CSS selector for username here, for password here, and for the login button here. Then I want you using CSS or XPath, it's up to you, you can choose, to perform the following operations here, which is adding an item to a cart, clicking on the cart, and then I think clicking the next button. And then here we will be use the best locators based on what I have taught you. You're going to fill out the first name, last name, and zip code, and then you're going to click the continue button. And then here I want you to use link text to click on the final button, which will be this button right before this page, this finish button, okay? And then you leave this in place, because if you have succeeded, then this test will pass. If you fail, this test will fail. So you keep trying until this test succeeds. And how you'll know it succeeds is when you have all the code filled out and you click the run button, you run this test, the test will pass successfully. Mimic this code exactly. And I want you on the keyboard practicing it. Don't just copy it, because it's really good for you to get used to using the IDE and using all of the command shortcuts. When you come back, I'm going to show you the answer. Okay, so hopefully you did okay. There was nothing too crazy about this exam. It might have taken a little bit of work to identify the elements, but that's this entire section is for you to practice this. So here is what the final solution looks like based on the requirements that I gave you. Here are all of the locators. The only thing that may have tripped you up were the compound class names as such. So right here, you might have used an XPath instead of CSS. I did CSS because I wanted to show you how you work with a compound class name using CSS selector. So that I have two of those here. You would have had to use an XPath. So that is the only thing that really would have tripped you up. Everything else was pretty easy. And then we'll run the test, which is the most fun. And we're going to see it go really quickly, blah, 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 blah. It goes so fast. And then you can see that it passed successfully. If it didn't complete the last stage, then we know that our locators weren't good. In fact, they would have failed anyways. So that is the final exam. That is how our test looks. And if you did it and successfully finished it, congratulations. That's really good, and I'm very proud of you. If not, maybe you want to go back and just review the information again to make sure that you fully attain it. But however, we're going to continue to practice locators over and over throughout this test, throughout this course, because it's a huge part of test automation. It's one of the key components of test automation, so you're going to get to keep practicing it. So it's up to you what you want to do. Anyways, talk to you later. So here we are at the end of the section. where we learned how to identify web elements using a bunch of different techniques. Identifying web elements is one of the most important things, especially for UI test automation, because that's what we do in order to be able to interact with elements. So this section was absolutely critical, not only for your future, but also for laying down a really good foundation so that you can better do test automation. Some important aspects that you need to take away from this section are: remember to use the best locators for your test automation. We never want to use absolute XPath and absolute CSS. Never ever. In fact, since I started in the automation industry, of course, I made the common mistakes that everybody does, but probably at least in the last 10 years or so, I haven't ever used an absolute XPath or absolute CSS, and none of my colleagues that have been in the industry for decades as well ever use it. There is never a need. The attributes that we do want to use for identifying web elements are an ID. An ID is one of the best ways to locate an element, and data attributes. Both of those are equally excellent. Data attributes are really nice because they are particularly unique, and we know that they will only be used for test automation. And so either one of those works really great. Sometimes you can use a class name if it's unique, and if it's not, you can use XPath or CSS to create unique combinations of different attributes to identify the element that you want. Remember, the element that you want will have a unique attribute about it, and you want to have only enough attributes to make it unique without doing anything extra, because any extra work that we do will potentially be a breakage in the future. And so that's pretty much it. You of course mastered XPath and CSS and all of the different Selenium locators. Now you're able to use it. We're going to continue to practice them throughout the rest of this course. And in the next section, I'm going to teach you WebDriver methods, which are now ways for us to interact with our application. We'll be able to do stuff like clicking, sending keys, doing mouse movements, dragging and dropping, and so many other fun activities with our web applications. So I'm really looking forward to seeing you in that section. Hope you're ready. Let's go. Welcome to the WebDriver methods section of this course. This is the other extremely critical section of the course, because besides identifying web elements, here we're going to learn how to actually interact with our web elements so that we can perform actions on them after we locate them. In this section, you will learn how to take basic actions on elements, how to get information from elements, and advanced element actions. You will also learn advanced browser actions, such as executing JavaScript, handling cookies, managing files, handling Windows frames, and working with alerts. So, in order to interact with elements, what are the methods that you have available? Well, so to interact with an element, first you have to find the element, which is exactly what we discussed in the last section, which is where we find the element. After we find the element, we can then interact with it with one of the methods. Click method, which you have already seen from Selenium WebDriver. This right here is called find and act, because this action right here locates the element, and then this one actually interacts with the element. This right here is called find, store, and act, because we find the element and we store it inside of a variable, and then we use that variable to interact with the element. This method is usually the preferred method if you're going to be doing multiple actions on an element. Let's say, for example, you want to type some text into an element and then also click on it. This is the method that you actually want to prefer, because finding an element is a WebDriver request. This is extremely important when we start executing test automation in the grid and running in clouds, which almost all of us are going to be doing in the future. And so it's really important to only make as few find element calls as we can. So whenever you're going to be doing multiple interactions on an element, such as typing in keys, such as making sure that the element is displayed before you click it, or that it's displayed before you interact with it. You're going to call this once and store your element into a variable, and then you're going to perform multiple actions with it, and that will perform only a single web request, which is extremely critical to your cloud test automation execution. Here are some of the methods that you can use to interact with an element. The click, which you have already seen before, which is just simply a click on an element. You have also a clear method that you can use to interact on an element, right? For example, you may imagine a text field that has some predefined text in it that says, type in your username here. You can click on that element, you can clear it before typing in your text. Then you also have the send keys method. The send keys method will allow you to actually send a string of keys into a specific element, such as an input, right? For maybe entering a username or a password. And finally, you can submit on an element. Submitting on an element means you can submit a form. For example, you fill out a username and a password, then you can submit on a button so that the entire form can submit, or you can even do that on a search field. For example, maybe you typed in a search string into Google. Now you can find the form element, or you can find the button element, and you can use the submit method, which is pretty much the same thing as a click. Those were element interactions. Now, what if we want to get back information from our elements to decide what action we want to take afterwards? So there are several methods for getting back information. There is the get text, right, which will provide you the text of that element. You can get a tag name, which will tell you what is the tag name of this element. You can get an attribute from that element, which is extremely useful for potentially deciding what is the state of an element. Now, you may be interacting with a React application or an Angular application, and they use attributes a lot. And so you might be able to get an attribute such as element is visible attribute that tells, maybe has a flag such as true or false, and then you can use that attribute to decide whether the element is visible or not. You can also use the isDisplayed method, which is natively out of the box coming from Selenium WebDriver, that will tell you whether the element is displayed, and also isEnabled, that will tell us whether an element such as a button is enabled for us to interact with it. Now be careful, these two methods may not always work depending how the HTML is implemented. So it's important whenever using these methods to make sure that when you use them, that they actually tell you the correct state of the element. A lot of times they will work, but sometimes they may not. And so it's just important to double check. For example, when you use isDisplayed, does it actually tell you that the element is displayed before? And for example, if the element is not displayed, if you try it, does it actually return you a false? Now let's talk about some advanced element actions. So advanced element actions involve really mouse and keyboard actions. We can do those using Selenium WebDriver. Not only can we perform the standard operations you already saw, but we can do stuff like hovering and doing keyboard keys and all that kind of stuff. Now, this is how it's done. First, you need to locate the element that you want to interact with, and we're storing it inside of a variable here. Then we do advanced element interactions using the actions class that is part of Selenium's WebDriver API. We create a new actions class as such, passing in your driver. After you have that driver, you can use a Fluent API to build the actions that you want to create. So for example, here we're using the action to click an element, right? This is the same as our mouse click, but we're using the actions API here to click an element, and then we're building that action because this is using a Fluent interface, and then we are performing that action. until you use the perform method, the action will not actually occur. So here are some of the major mouse actions that you can do on web elements. So take a look here. We've got a click where you will just click on the middle of an element and you just pass in your web element. We can do a click and hold. So if for whatever reason you need to hold down your mouse on an element, you can use the click and hold method, again passing in an element on where you want to perform the click and hold. We can do a context click. A context click is nice because it will move to the element and then it will click on it. We can perform a double click, which is exactly what it sounds like. We can also do a drag and drop. A drag and drop is very common for UI test automation. And so what you can do here is grab an element, right? And this is the element that you're going to pick up, and you're going to drag it to some specific target, which will be another web element. You can also do a drag and drop by. So you can pick up an element and drag it to some specific location. You can move to an element. A lot of times what will happen in pages where they are dynamic, a page may not be rendered until you scroll to an element. An element may be below the fold, below the visible region of a page. And so that's when you may want to do something such as a move to element, where you move to the element first and make sure that it's in your view of the screen, and then you can start interacting with it. Actually, a very common error that many students and many automation engineers get is element not clickable exception, because they try to click or interact with an element before it's actually in the viewport. And so a very common solution to that is to move to the element first before interacting with it. This is another move to element method that you also have available, where you can pass in the element that you want to move to, and then you can pass in the coordinates of how far you want to move to that element. And then finally, you have the release method. The release method will, if you, for example, are doing a click and hold and you're holding down on an element, at that point you can do a release to release the mouse at that element and stop clicking and holding. There are also keyboard interactions. Keyboard interactions are extremely helpful if, for example, you cannot interact with an element using standard mouse commands. Now, I do really want to caution you here that keyboard commands are extremely flaky and should be used as a last resort in your test automation. However, I have been in situations where you cannot do stuff with regular mouse actions, and so keyboard commands come in very handy, but you should work very hard to make sure that your keyboard commands are the last thing that you're ever using, and they should not be the first thing that you're trying to use. However, there are these actions that you may want to perform. There's the key down command, which will simply press the key down. So if you want to send a bunch of characters, for example, like pressing the enter key or pressing the up arrow, or maybe you want to pass in a function key, you use the key down. Now, after you use a key down character, you have to do the key up character, so that once the key is pressed, it will not be released until you do a key up. And then you can also even do the send keys, which is exactly just like send keys that you've seen with a total input box. And here you can send keys to any element, right? Maybe, for example, you want to send keys to the entire browser, such as opening up developer tools. You can do a send keys here by passing in those keys and passing them over to an entire browser versus just passing into like an input box, for example. And here are some code examples of what we would do to, for example, do a hover, right? So we have our action element. We will move to the element, passing in the element that we want to move to. we will build the action and we will perform it. Here's an example of a drag and drop. We'll have our action class. We'll do a drag and drop method that's provided to us by Selenium. We'll take element 1 and drag it over to element 2, and then we'll build and perform. Remember that nothing happens until we call the perform method. Then we can do a click, pause, and release, for example. You can click and hold an element, pause it for a specific interval, and then you release that click and hold, and then you perform the operation. You always have to perform again. This is using a Fluent API where we can build this into a very long string, and until we call the perform method, that string will not be performed. All right, I hope that you are ready because I got an awesome quiz for you. I worked on this one for a while to try and exercise all of the new skills that you have learned so far. Let's go ahead and go over it. So all of the requirements for the quiz are going to be here at this Git gist that you can find. I'll also, of course, supply you the URL in your course resources, but I'm going to go through it here as well. So you're going to give me 5 tests. Each test is going to have separate requirements. Test number 1, you're going to navigate to this URL. You're going to select option 1 from the drop down, and then you're going to assert that option 1 is selected and option 2 is not selected. Let me show you that manually. So you're navigating here, coming here, selecting option 1, and then doing 2 assertions. Option 1 selected, option 2 not selected. That's test number 1. Test number 2, you're going to go navigate to this URL. You're going to hover over the first image, and then you're going to assert that there is text displayed below the first image, which says name user1, like this. Let me show you. So here are the hovers. You're going to hover over this image and then see the text there that says name user1. You're going to assert that that text is actually visible. Next, you're going to go to this URL right here. You're going to right click in the box. You're going to close the alert. And I know you've never dealt with alerts before, so I'm giving you a hint here how you can accept the alert after it has popped up. So this is what you're going to do. See this box here? You're going to come here and you're going to right click. See this alert that comes up? That's how you're going to dismiss it. And by dismissing it, actually, that is how you know your test will pass. Because if you try to dismiss it and the alert is not there, your test is going to fail. Next, you're going to navigate to this URL right here. You're going to send the right arrow key into the input box, and then you're going to assert that this text is returned from the element. So let's take a look. You're coming here, you're putting your cursor in there, you're going to enter the right arrow key, which I did right now, and you're asserting that you got back this text right there. Finally, you're going to navigate to this URL right here. You're going to find an element with text, clickable icon. You're going to assert that its href attribute is equal to this URL right here. Then you're going to get a CSS value called background origin, and then you're going to assert that it equals padding box. Let me show you exactly what that looks like. So here is that URL. You're going to find this clickable icon, and actually, since I've never shown you anything about CSS before, let me explain about it a little bit more. So, as you can see, I am now hovering over the clickable icon. On the right-hand side, you can see all of the CSS values. If you come here and click computed, it will actually show you a bunch of CSS values that have been used to generate the style for this clickable icon link. So we are actually looking for this one here. So this is actually the key, and this is the value of that CSS. So we're passing in this key and we're expecting back this value. Let me just double check that I'm talking. Yup, exactly. And so that's exactly what we're going to be asserting. You should already know the method for getting a CSS value from an element, and so that should not be a problem. Okay, cool. So go ahead and enjoy. Give me 5 tests. Spend a good amount of time on this. This is going to take you a little bit of time. It's going to take some effort, but you should know how to do this from this point forward. And then when you come back, I'll show you the answer. Okay, cool. Let's see how you did. Hopefully that wasn't too bad. It was challenging, I'm not going to lie, but it's meant to challenge you and it's meant to push you to your limits, because whenever you're in the workplace, you're going to be pushed to your limits because there's always new technologies and always new situations to encounter. So my goal is to teach you, but also to push you a little bit as well. So anyways, let's go ahead and check out what is the solution. The very first thing we want to do is, of course, run all of these tests, which is the most fun part, is seeing all of this being executed. It's going to be extremely fast, but it's okay. And it's actually, unfortunately, running on my other screen, which you're not seeing right now, but no big deal, because we can see that 5 tests have passed, which is the ultimate sign. Now, let's talk about the solution here. I've created a class called WebDriver Methods Quiz. That's where I've placed the solution here. I've created a class level element named WebDriver and Web Element so that I don't have to keep instantiating these in every single one of my tests. We are using the before hook as before, where we're doing a setup and we're creating a new Chromedriver. We're using an after hook as before, where we are doing a teardown and just quitting the browser. Now let's take a look at the rest of this code here. Okay, so here is the very first test. Let me expand out the solution and you can see what we did here. So here is the navigation. Here is me finding the element called drop down. And then here's simply clicking on that element. You first have to click on it. Okay. Next, based on that, you can actually, and this I didn't teach you, you could have done it another way, but I wanted to show you a different way that you can do it. Is once you have an element, see how we stored the element in to a variable here? This is one WebDriver request right here. So here, the Chromedriver sends one web request to your browser saying find element by this ID, okay? And now we have it stored in this variable once it's found. And so now every single action afterwards is not going to cost more web requests in terms of finding an element. So here we're clicking on that element, and now here we can use this element that we found to dig into its children and find more elements inside of it. See the beauty of that? So we found that element, which was the drop down, and now we're going to find elements inside of that, which are the option value 1 and option value 2. Let me show you exactly what I mean here. So look, if we come over to this page and I inspect this, let me scroll up a bit and zoom in a bit. There you go. So look, once I select this drop down, which we found, you can see that inside of it, it has children, right? And so once we have this located, we can do a find element and just search its children. You could have obviously also found elements by doing element with ID drop down hashtag, and then look for different option elements, right? Or you could have found a child of this element. There's a number of ways you could have done it. I decided to go this route. And so that now I have my elements option 1 and option 2, which are corresponding to option 1 and option 2 in here, okay? So with that said, I'm going to click option 1, and then I'm going to assert. Here are some of the methods that are used to get information back from the web element. So here I'm checking that it is selected because we selected it. And here I'm checking that option 2 is not selected, and I'm doing assert false that this is selected. I also could have done obviously assert true and then have a not option 2 is selected. Either one of those. And you saw this run already, but let's run it again and hope that it comes into the right screen. You never know how these things work out. There it goes. You can see it's selected and it passed successfully. So that's solution 1. Let's take a look at solution 2. For the hover, we are navigating to the hover page, and then we're finding the element by class name figure. Here I specified the first image, so it doesn't matter that there are 3. When you specify find an element by some locator, and that locator, there are multiple of those elements, that will always pick the very first one. And so it worked out perfectly here for me. I just used class name and picked the first one, no problem. And here is us using the actions class, and we are moving to the element. Here's the element that we found. And then don't forget that you always need to perform with the actions in order for it to actually happen. Now, you could have done a build, but a build, all that does is it builds this into an action object. And so then I could have stored this into an action object. And if I wanted to repeat this multiple times, let me actually show you here better like this. I'm going to just do this here and comment that out. And let's call this move to. And that's in. There you go. So see that? So now if I wanted to do move to many times, I would just do this. And then if I needed to do it in the future again, I would just do the same thing. Just like that, okay? So that is the purpose of build. Although I have rarely used build, it might come in handy, again, if you need to repeat an action multiple times. So instead, we can just always use perform. Of course, perform is not going to return us an action. And so we can always use perform, and that will automatically just execute that action. So we executed that action, and then as we were hovering over that element, I checked for this other element to contain this text, and then I checked that it is displayed, because if it's not displayed, then this will return us a false, and so then it will fail. So I can show you an exact example, right? I can change this to user 2, which we will not be hovering on, right? Because we're going to be hovering on the very first icon. And so now I'm going to run this, and you're going to see that it fails because it's expecting the string user 2. However, we get the string user 1. And you can see it failed. And then let's come here, take a look at our assertion message. And look, it says here, assertion message, user 1 should appear because we hovered over that image. And then we can, of course, expand this right here. If I can click. There you go. And we will see here at the top that our hover method failed at line 78. Not a very friendly assertion. So one of the things I'm starting to recommend to you from this point forward is always try to use messages inside of your assertions, because they will make your error messages that much better for debugging purposes. Getting back friendly error messages is extremely important for test automation, and it's something that most automation engineers unfortunately do not do. So I'm letting you know, do it, because it will really help to get your mean time to resolution, which is a very important factor in good quality test automation, to be that much quicker. Okay, let's talk about the next test right here, which is the right click. Now, to right click, all you have to do is find the appropriate element. You use the actions class, you do the context click, which is also a right click, And then that's it. And then you perform that action. And then I already told you how to switch to the alert and accept it. Let's go ahead and run it so that you can see that I'm not making this up. There it is. So our test passed. That one is probably the simplest one of all of these, right? Next, we got the key presses. The key presses, you just navigate to the URL, find the element. This should have been super easy. And then you click inside of that element, because in order to be able to pass in the keys, you have to click inside of it. Then I use the actions class again, which you should be very familiar with now. And then I am sending the keys. And then, oh, this is one thing I should have pointed out to you. And that's kind of my fault. I apologize for not pointing it out to you. But Selenium provides us a very nice enum called keys that allows us to pass in whatever element we want, whatever action we want. So look, we can do keys dot, and you can see that there is a bunch of different keys that we can pass in, you know, from F1 to home to insert and so on. And so I was just able to basically pass in a right arrow. All of this ultimately boils down into string. It boils down into string commands that are then transformed into keyboard commands. But you don't have to worry about that. Just know that you can use the keys command, or you can actually pass in characters in here. You can, for example, pass in like special characters that will signify a right arrow or alt or option and so on and so forth. So I did a pause here just in case to slow down the test and also show you how to use the pause method. And then I also use the perform in order to execute the action. And you can see here how I'm building up these actions together, and I can chain as many of them as I want, and then I can do a perform. Okay? So then after I did that, I checked this element for the result, and then I made sure that we got the right message, which was this string expected right here. So I can even change this, and you will see that it fails if I do this. See that? Test failed. Let's read our error message to see if it's friendly. Look, this is one of the reasons why I love assert equals, is because it's so easy to understand what happened. Look, so clicked a right arrow key, okay? Expected this, but got back that. So of course, we modified it, so we really should be expecting this back. But look how much cleaner it is and easier to understand exactly what happened versus the previous error. So let's return this back, and then obviously you know it will pass based on the error message. Okay, now the final question, where we navigate to this URL, find the element by link text. That should have been super easy for you. Then we get the attribute. I told you about this ability to get information from elements, and we simply just get the href attribute. And so that will, of course, return the value of that link. So if we go back here and come here and we inspect this element, here's the href attribute. Yes, here it says that it returns only this partial, but actually this is because of the way the application is coded. It will return you the entire URL. It always will. So then once it does that, we assert that it equals to this value. We assert equals that this is equal to this link, which is very easy. And then we just get our CSS value, which I told you about this method as well, but we've never used it. And so this was your opportunity to use it. And all you have to do is just search for the string, and it will return you the value of that string. And I already showed you that result here, which is basically we are just asking for this string and asking for its key. You can select any number of properties here that you want, and I've seen automation engineers even checking RGB values. It's totally unnecessary. It's something I would do with visual validation, but if you wanted to go that route, you certainly can, but I would really, really strongly discourage it. But also, I wanted to show you these CSS properties so that you know that they are available, so that if you do need to validate different kind of stuff like CSS values, you have that capability. Okay, cool. So I hope you really enjoyed this quiz. I certainly enjoyed giving it. Of course, I'm always here for you. Let me know if you have any questions, and see you in the next video. In this video, we're going to talk about the JavaScript Executor, which is an interface from Selenium WebDriver that allows us to actually run JavaScript code in the client-side browser. JavaScript code is extremely useful to be able to run in the browser because it allows us many different types of operations that are not natively available through the Selenium WebDriver API. And so using JavaScript execution, we can do all sorts of cool things. This is potentially one of the most useful videos in this course because this is a very common use case where using the JavaScript executor. So how it works is we have the JavaScript Executor interface that comes from our Selenium WebDriver package, and we use our driver and we cast that driver into a type of JavaScript Executor object. So you can see that now this JavaScript Executor object is stored inside of this variable, and then we use this JavaScript Executor to execute script. Now, there are actually two methods on the JavaScript Executor interface. There's the execute script and the execute async script. However, almost nobody ever uses execute async script, and the most common one to use is execute script. So in this case, for example, you can see we're passing in some string, which is actually some JavaScript code, and this string will actually pop up an alert on our browser. Here's another example of how we can utilize JavaScript, and don't worry, we'll get our hands on more JavaScript code with actual practice. In this example, you can see that we're doing our normal find element, storing that inside of an element object. Then we're creating our JavaScript executor, again, by casting a driver into a JavaScript executor interface, and then we're using it. In this case, we can do a click using JavaScript. See that? It will do a click. So as opposed to Selenium WebDriver, which does a web request, it actually sends a web request through the wire to do a click. We can do it from client side, meaning through the browser using JavaScript, we can click. This is a very common, very useful situation to do with JavaScript because a lot of times a WebDriver request may not be capable of doing a click. I've seen that multiple times, and so we can bypass that by using a JavaScript click or some other type of click that may be available through our native web application API. Here's an example of how we can do a scroll with JavaScript. So you can do the window.scroll by and say how far you want to scroll, and this is another example of that. In this video, let's talk about windows and frames because they are more challenging. I want to show you actual code examples so that we can completely comprehend everything that's going on. So we are inside of this class here, inside of our solution. Make sure you check all of your imports and everything is set up exactly like before. Have my driver, have my element, have my setup, have my teardown, and then we are inside of this Windows frames method. So let's actually step through this code so that you can see exactly what's going on. So I'm going to throw a breakpoint here. I'm going to do a debug, and then we will analyze the code as we step through it, and you will learn a bunch of important methods here that you have not seen before. So this will obviously just navigate to the URL. So we're going to use our debug window to step over. And so now if we come here, you can see here we are at this new URL where it gives us the possibility to open a brand new window. So actually clicking this link opens up a brand new window. So rather than clicking it, I wanted to show you some JavaScript execution so that you better understand what's possible with that. So here we are creating our JavaScript executor, and I'm just going to step over it, and you can see that now we have our JavaScript executor object. You can see that it exists down here, and it has different properties and methods associated with it. Now, using our JavaScript executor, we can execute script. Again, as I told you, we can execute any JavaScript that we want. And so a command in JavaScript to open a window is this. and then we are going to navigate to this URL here, and that will actually open a brand new tab, which is also known as a window in Selenium. I think that's an unfortunate naming of the windows in Selenium. Really, they should have named them tabs, and then it would have been tabs and frames, but they named it window, which is fine. But just remember that window is synonymous with a tab. And so this will open up a brand new tab to this URL. So let's actually go ahead and step over this, and look, right now we have a single tab, and now we're about to have 2 tabs. Boom, see that? So now we've got a brand new tab on this URL open. So now let's proceed. Here is a new method that you haven't seen before, and this is from the driver object, and it's called window handle. Let's step over it. And what this actually does is it provides the unique ID of the current window that has the focus, the current tab. And so we haven't switched to any new windows yet. So if you were to guess which tab has the focus right now, it is the first tab. That is why I called it the original window. And that's why I've stored this unique ID into this original window variable. And so you can see when we get the window handle, it actually this returns this unique identifier, and which is just a string, and then we can use it to identify which tab we are actually on. Okay, makes sense? And you can see the unique identifier down here. Now, if we call driver.getWindowHandles, it will get us all the tabs that are currently open. So if I step over this, you can see that now I have an object, a set, which is a type of object, a set of handles. And you can see that down here. Always be looking at your variables and be reading what's going on. Look, I have handles. You can see that it says it's a size 2. If I expand it, look, I have the first element, which, look, it matches to our original window. See that? You can see the ID matches up to our original window. And the second window, which has its own unique identifier. So this set allows us to know all of the tabs that are currently open. So then I'm simply using this handles object to remove the original window from the set. So let's step over this and see exactly what happens. Now look, we only have one object in the set, and it's the second one. Look, remember our original window? This is our second window. So now, here we are just getting the value of this object right here using the handles.iterator.next, which are just methods located on the handles object. And so we'll just step over that. And so then that gives us that next window string. Look, here's the next window string. Here's the original window string. We've stored both in variables, so they are now available here. So now at this point, we can switch to the second window. So look, with driver switch to window, and we're going to switch to the next window, which will be that one. Okay, so let's step over it. And nothing new really happens in the browser, but it happens underneath that you know that now this new tab has the focus. And so actually that's exactly what we're going to check is, how do we know that this new tab has the focus? How do we know that everything that I just been telling you isn't a full crock of BS? Well, because we can check the title of the window. Look, this window is called new window, and we can use driver.getTitle method to get the current title of the page that we are on. And I can show you that this actually has that title because we can right click and we can inspect. And in every HTML, there's a head element, and inside of there, you can see here is the title of this page right here. It's called new window. So if we assert on this, it should pass. And there it does pass. So now if we use the driver.close method, it will actually close this window that we are currently focused on. So let's step over that. So that is really the only use case for driver.close, is to close different windows whenever you want to close them. Now, driver.close has a different behavior. If there's only one tab open and you use driver.close, it will actually kill the browser as well. However, we ultimately never want to use a driver.close to end all of our sessions, because it will not work whenever we go to remote WebDriver execution. We always want to be doing driver.quit. That's actually why we have this in our teardown method. So driver.quit is always the way we want to kill the session, even though driver.close will currently kill the session if I call it, because there's only one tab open. Okay, makes sense? Even though it has that behavior, don't use it for that. Use driver.quit for quitting the session. Use driver.close for closing the tabs. Okay, so now here we're going to switch to our original window, which now it has this focus. And so with that said, we should now get this title, and it'll be a brand new title because it was our original window. So again, let me show you that I'm not just making stuff up. We'll come here, we can go into the head, and then if we go into the title, you can see that it says the internet here, right? So I'm not making stuff up. Let me close this. And let's do this final assertion. And it has passed successfully. We can finish the execution by clicking this button, and you can see that our test has passed. So that was a very in-depth moment where you just learned a lot of important methods and a lot of important functionality. Let's talk about frames. Frames are pesky little guys because they can throw any automation engineer for confusion when an easy to find element is not able to be found. And frames are ultimately like embedding one HTML page inside of another HTML page. And frames are pesky because if you don't switch into the appropriate view, aka the appropriate HTML page to interact with the elements, you'll get a no such element exception. It will be like you're not even on the correct page for trying to find an element that should exist. Let's discuss this further so that you better understand. So take a look at this URL over here, okay? If we look into this HTML, you can see that we have this frame set, and inside of this frame set we have two frame elements, right? You can see the tags here, frame 1 and frame 2. You can see when I hover over them where it highlights. Now, anything that we try to find inside of frame top can be found only by switching to frame top. So let's look inside. Open this up. You can see that in here is its own entire HTML, right? You can see it has its own HTML body, it has its own head, and it has its own information such as the text that is called frame left. And you can see even it has multiple different frames inside of it. It has a frame left and a frame right and a frame middle. And you can only get to these frames after you switch to the parent frame. So in order to get to any of these three, you have to switch to this one first, and only then can you find these elements and start interacting with them. Otherwise, you're going to get a no such element exception. Does that make sense? Let's talk about another example. Frame bottom. If you want to see anything inside of frame bottom, which can be located by its name attribute, you have to switch to it, and once you've switched to it, only then can you inspect the HTML and potentially get something like its body and read the text of the body. Let's take a look at the code. You can see here that I am inside of a method called frames. Let's start debugging this and you will better understand exactly what we just talked about. So the very first line, standard, is going to navigate to that URL that you just saw. Now, we can switch to different frames by several mechanisms. One of them is by switching by index. Index now in our case, because we are currently at the top level frame, meaning that we are here, we can only see two frames. We can see this frame and we can see the bottom level frame. So we can either switch through 0 or through 1. So I'm going to switch to the second frame, right? The second index in our frames. And so now you can see that if we perform this assertion on this element looking by the body, it should return bottom because we are currently focused on the bottom frame. Let's step over that and see how that worked. Now, there is a switch to parent frame method that comes with the Selenium WebDriver API. Parent frame will simply move the focus to the top level frame, the parent frame of whatever frame you are currently in. That doesn't mean the very default frame, right? In our case, if we have 3 frames, right? Frame 1, inside of frame 1 we have frame 2, and inside of frame 2 we have frame 3. Switching from frame 3 using parent frame will move us to frame 2, and the parent frame of frame 2 will move us to frame 1. Hopefully that makes sense. So now in this case, we are going to switch to the very top. So see that? We can also switch frames by simply passing in their name. Frames should have a name, and so we're just simply referring to them by their name. So this will take us to the top frame. This will take us to the left frame right now. And so now if we try to find the element by the tag name and get its text, it will return left. If we try to do, it will not ever find us a bottom because we're simply not in that view right now. We are exactly in this frame right here. We can't interact with any elements in this frame. We can't interact any elements here or here. We can only do stuff that is inside of this HTML body. So if we do that, it'll return us left. Now, default content, that's an important one. This one will simply take us to the very top of the HTML. It doesn't have anything to do with frames. It just basically takes us up to the very top. So if we were very nested deeply inside of iframes, we can just get out just by going all the way to the top. So for example, let's step over this. So now I'm at the default content. So let's pull out our little inspector and let's see if I have. So now, for example, if I try to find frame top, do you think it will work or not? We are at the very top HTML level. Yes, that will work because remember at the very top HTML level, we have both frame top and frame bottom. So let me see, I don't have frame bottom here, but I can just change this. And, oh no, that didn't work because, oh yeah, I guess you have to go navigate into frame top to get into frame bottom. So look, that failed. So look what happens. If we switch to frame top, oh, I know what I did. I switched to frame top and of course it couldn't find frame bottom because it's inside of frame top now. So if we switch back to default content, and then we find element frame bottom, will it find it or not? Yes, there you go. It should find it because at the very top level we have frame top and frame bottom. Sorry for the confusion. Now, if we wanted to find frame left, will it be able to find it? No, it will not, because we need to get inside of frame top to be able to find it. So switch to frame top, execute that, and then now let's find frame left. See that? It does find it. So if we want to get out of all of this, not care, and just start interacting with the rest of our elements, we've dealt with all the information in the frame. That's where you use the switch to default content. And so that is the purpose of that. And so now actually let me execute that so this doesn't break. Switch to default content. There we go. And now if we do this assertion, of course, it'll find frame top because it has those two at the very root of the HTML. So now you know everything there is to know about frames. Let's talk about how to handle alerts in Selenium WebDriver. Alerts in Selenium WebDriver are actually really easy. The API is super nice and you should have no problem handling it. Let's go ahead and navigate to this URL and I will show you exactly what's going on with the alerts. So here we are on this web page. We can click each of these buttons and get different alerts that pop up, and we will handle them in different ways. So I'm going to find this very first element, looking for this text, which is going to click this JS alert. And by the way, I wanted to throw out something cool here and very key that many automation engineers don't know, and that's the use of normalizing space whenever looking for text, because actually it's possible that the spaces here may not be totally correct whenever elements render. There may be two spaces or stuff like that. So you need to use this functionality, this method from XPath that will help you to make sure that the spaces are normalized with this string. It actually makes your locators more stable. Anyway, so I use that. You can see that example of that there. We're going to find it, and then we're obviously going to click it. So let's go ahead and do that. Now let's look over. See that? We've got a JavaScript alert. Now, the annoying thing about JavaScript alerts is that whenever they happen, you can't interact with the HTML. Look, I'm trying to right click. I'm trying to click here. You can't do anything with the HTML until the alert is dismissed. And that's where alert handling comes in handy. So in order to dismiss this alert, it's actually really easy. Use driver.switch_to.alert.dismiss. Let's step over that. Boom. Look, alert is gone. Let's click on the next alert, which will have a JS confirm. So let's click that. And so now we have this alert. You can see now this alert has a cancel button and an OK button. And so in this case, we can accept the alert by using the accept method. So let's go ahead and step over that. And now the alert is going to be gone. See, alert is gone. And now we're going to get a JavaScript prompt that will allow us to input text. So let's find that and click that button, which will then prompt a new JavaScript alert that we can see looks as such. And you can see it has input text and it has two buttons. Now, the other thing that's important here is you can actually store a JavaScript alert into an alert object that comes from the WebDriver API. So we're getting this alert here actually returns an alert object, which we then store in our input alert variable. And now we can just use this alert object to perform multiple operations, such as getting the text, which would then returns, look, I am a JS prompt. That's the text that's coming from here. And then we can send keys. Look, mom, I can automate alerts. And then we can accept it. And then when we go back to our HTML page, we can see that we entered, look, mom, I can automate alerts. Congratulations. And we finished this test as such. That's all there is to alerts. Let's talk about managing files and cookies for some advanced browser interactions. So the very first thing that I need to say is testing file upload and download is actually not necessary when it comes to automated software testing. We have thousands of requirements and thousands of test cases, and doing this functionality through Selenium simply doesn't make sense. Yes, it's possible, but there are more stable and faster ways of doing it. In fact, you can see a recommendation here from selenium.dev themselves. Because, for example, a file download is simply an HTTP GET on a link. For example, if you go to this URL right here and you try to download any one of these files, every single one of these points to a link, right? You can see that each one of these is a link. And so if we actually want to validate that this file is downloaded, all we have to do is check that the link is correct. And the click itself, using Selenium to click on this link, is likely not to be broken. In fact, if clicking a link doesn't work, it means that it's broken for the entire web. And so the click is absolutely pointless. It's a waste of time, not only for our coding efforts, it's a waste of time in terms of test execution time, and it's also a waste of time in terms of maintenance. Only the link itself can actually be broken, because what happens is this file right here can be disjointed from the correct link. You might click it and get an invalid status code. And so that's the only thing we want to check. Validating that we can actually type in a file name in here, click the save button, that it actually appears on our operating system is not needed to be tested, because this is a native operation of our operating system. And Windows and Mac have already tested that their operating systems are working for us. And so we don't need to test this. There is absolutely no way that this can break unless Windows or Mac introduces a bug into their system, in which case this will be broken for everybody using that operating system anyways. So the correct way to test the file download is already, as I have mentioned, is using an HTTP client. So in this example, I am showing you using rest assured, okay? And so you can see that I've set a file path of the file that I expect to exist. Then we do a GET, an HTTP GET. If you're not familiar with web requests and responses, that's no problem. That's totally outside of the scope of this course. But if you do want to know how to test it correctly, this is how you do it. And so then you do a GET on that URL, and then you get back your response. And then the response should be a 200 status code. If this file doesn't exist, for example, you might get something like a 400 status code that says, hey, file not found. And so in which case, you know that clicking that link would have been broken because the file doesn't exist. Let's also talk about cookies. Cookies are pretty important, especially in terms of when it comes to like logging in or setting user preferences. And you can do it several ways in Selenium WebDriver. We can use our cookie builder to build up a cookie that we want to set. So for example, if we wanted to drop an authentication cookie to log in as a user, we can build it up like this by giving it a name and a value. We can add all of these different properties here and set them to whatever we need to set them before dropping that cookie in the browser. Once we have it, we can add the cookie to the browser using the add cookie method. If we want to make sure that we have a cookie in the browser, we can use the get cookie named method and simply provide the name of the cookie. And if we want to assert that we got the correct cookie, all we have to do is use the get value method, and that will let us know whether the cookie we have set the correct cookie or not. And of course, if you want to delete all the cookies in the browser, you can, because sometimes cookies can actually impact the behavior of a browser. For example, you might have a cookie from some advertiser that has been dropped on your browser, in which case you might get certain advertisements, or even maybe your website might change in certain ways. And so it's sometimes important to delete all cookies so that users aren't logged in, or so that the application behaves as expected. Let's go ahead and put all of our knowledge to the test with a really fun exercise. So what I've done here in the project is created a WebDriver methods exam where you will find all the code samples. And what I want you to do is, in this WebDriver methods exam, create a setup and a teardown, just like we have been doing before. And we're going to do several tests here. In the first test, I want you to navigate to this URL, which you can see here on the right-hand side. I want you to focus on this element right here, so you can see that when I put my cursor in here, it gets focused like this, and this orange outline comes. And then I want you to assert that that element is focused. And I gave you the selector right here using a CSS selector. We want to start practicing those more often. Okay? Next, I want you to navigate to this URL. Then you're going to set a cookie using this button. Okay? Then once you set the cookie, you're going to get a cookie name token. In fact, let me show you where to analyze the cookies. So you can come here and then come to application. And in our application, we will see cookies. You see we have a cookie from example.cypress.io. And you see we have this cookie name token, right? So you're going to get that cookie name token, and you're going to assert that it has a value of ABC123 or 123 ABC. Next, you are going to come to this page right here. You're going to scroll to the bottom of the page using a JavaScript execute command. This command is really useful for scrolling through pages. It's actually also very useful for visual testing. And since you've never done these commands before, and it does take some Googling, what I did is I actually provided you the command you want to use. So you'll use this one with the JavaScript Executor, and then after you'll want to do a thread.sleep for 1,000 seconds. And this method always forces you to throw a interrupted exception. So you will just need to do this exact line of code. And in fact, if you use your IDE, it will guide you into it and force you to do it. Finally, instead of scrolling to the bottom, now we're going to scroll to the top, doing pretty much the same thing as scrolling to the bottom, but it's reverse. So you can see here we're doing the negative of that. So you want to scroll down again, and then you want to thread sleep for 1,000 milliseconds afterwards. And that's pretty much it. Give that a shot. When you come back, we will see how you do. Okay, so let's analyze this exercise here. So what I've done at the very top is I've created 3 fields: a driver, an element, and this field called JavaScript Executor. I'll show you exactly how we use that. And this is just so we can reuse it in each one of our tests. Okay, obviously in our setup, I am creating a brand new Safari driver. And if you remember from previous lessons in your own Mac, Safari driver actually doesn't even require a WebDriver manager. So we can just simply use it. Next, I'm using this command here to maximize the window. Now, you didn't have to have this command, but I actually strongly recommend it for all automation. Having a window of the browser in a constant state all the time will make your test automation drastically more stable. So you should start doing this in all of your test automation and making sure that the window is maximized. And then over here, you can see that I'm simply setting the JavaScript Executor to this field right here, so that I can use this instead of having to repeat these 2 lines of this line of code everywhere. I'm just going to be using this JavaScript Executor. It's just a way to minimize the code. And then the teardown is just simple driver.quit. So now in the very first test, in our actions, let's go ahead and run it, and you will see that it passes. So hopefully you saw it there very briefly, how I did highlight the element. The test did pass. And of course, you can pause the video to make sure that it did highlight. And here, it was pretty straightforward. So we are actually just finding the element with the CSS selector that I gave you. And in fact, let's take a look at that page. Just so you better understand exactly what's going on here. So if we come here and inspect this, what I want you to notice is, right, this element is the one highlighted, and this is the one that has a style change, right? So let me refresh this page again. So you can see that right now, this field right here has no style change because it's not focused, right? And if we do decide to focus it by doing this, you can see that now it has a style of color orange that has been added to it. And so that's actually the part that we were supposed to check. So we got that element, we moved to the element and did a click. We could have just as easily done a driver.find element and then just do a click on it. That would have been the same thing because it would have focused it. And then all we had to do was find that element that I just showed you, which was this one, and check it that its style contains this. So you can see that we used XPath here like this, and then we got its attribute style, right? Because this is the attribute that we want to retrieve, and then that it contains that color. And so that was that. Next one is the cookies one. The cookies one, we just navigate to the command, to the URL, and then I got the cookies locator using this right here, another CSS locator. We can pull this page up and inspect it as well. So if we scroll down and take a look at this, see how it has this set a cookie portion of the class. And so that's exactly what we used. And actually, I'm realizing that we don't even need this part right here. We could have probably just done that. And then we just click it to set the cookie. And so then once that happens, let's go ahead and check that out. So in fact, I'll show you my application right now. You can see that cookies, there is only this one, okay? And so, well, and actually it doesn't matter because running on this will not change anything. But if we do click this button and then refresh, you can see that now I have two cookies, this one, right? So that works, and then that's what we're checking here. And so what we can do is execute this and make sure that it passes. And the way we're getting the cookie name token, right? Here's the cookie name. And then we're checking that it has a value of 123 ABC. Here's its value. Let's give this a run. There you go. Test was successful. Let's go to the next one. In this one, to scroll to bottom, I basically gave you the answer. All I really wanted you to do was use the JavaScript Executor.execute script command, and it was just passing in the exact same string that I gave you and then doing a thread.sleep afterwards. Nothing special about this one. Let's give this one a run and you will see it scrolling through the application, scrolling to the bottom. And as I said, this will be very useful for you for visual testing, because in visual testing, what's going to happen is elements will not be rendered until you scroll through them. So this is the way you're going to be able to do that. And then this one was a little bit trickier because how can you scroll to the top if you didn't scroll to the bottom? So here I was expecting you to think a little bit and realize that first you need to scroll down and then you can scroll up. So let's run this one to make sure that it works. So you'll see it scroll down and then scroll back up. There it is. That's it. And that's pretty much all there is to it. Hopefully you did okay. And now you have some really useful code that you can use for your future test automation. Let's talk some more about page objects. Page objects are an extremely important pattern, especially with UI automation. If you haven't heard of the page object pattern, it basically states that you should encapsulate your UI HTML web pages inside of classes, whether you're using, Java, C# or other programming languages, you're encapsulating a single web page inside of a single class. And so page objects are phenomenal for test automation because they improve maintainability, right? For example, if you have a Google homepage, what's going to happen is all interactions related to the Google homepage will be living in the Google homepage class. And so whenever you need to update anything in the user interface or inside of your test, all you have to do is go to that page object and update it there. And you know exactly where to update it because, right, a Google homepage page object relates to the Google homepage, google.com homepage. It also improves readability, as I'll show you more tests and actual real code of using the page object pattern. You will see that your tests become extremely readable, and also organization is improved, as I mentioned, because the structure of your test automation framework will be much more intuitive. So here is an example of a good page object. You can see that up here, this is a class called Ultimate QA Homepage, and this class represents this entire web page right here. Inside of this class, we have some properties and some methods. For example, we have this property called the Start Here button, and you can interact with this property by performing different kind of actions on it. It encapsulates this Start Learning Now button here. And if you want to perform a method on this page object, you can do something like an open, and the method does exactly as you would assume it does. Is it goes to a URL, and that's pretty much it, right? It opens up the URL of that page. Let's actually take a little bit of time and code out a page object so that you better understand how to do that process. So here is the page object that we're going to code out. We're going to code it out for this URL here. And remember that a page object, all it does is abstract this HTML page into classes. Now, it doesn't have to be one class, it can be many classes, but we're just hiding the implementation details inside of a class. So let's go ahead to our IDE and start coding that up. So we can come here and I'm gonna right click and add a new Java class. So the very first thing critically important is what is the name that we give to our page object. The page object should represent the name of the page or component that we're going to be abstracting out. So because our page object here is called inventory.html, and then this has a product, I'm going to call this the inventory page. So again, and we're going to do that. And so now we have a new class that is called inventory page. Now this and let me grab the URL just so you have the comments. There you go. So now, what is inside of this inventory page? Well, number one, there are a bunch of products, right? We have this Sauce Labs backpack, for example. So we can go ahead and add that to our page object. We can add a new getter, which will be private. And then here, we're going to use our driver. And of course, it needs to return this element. So here you can see that we have a Sauce Labs backpack, and it's stored in a method which returns the location of that backpack. Some important things to note here is that this method is private because most of the time you don't want this to be accessible outside of the page object. Now there are different ways. Maybe someone wants to add it to a cart, in which case let's code the add to cart method, right? Always thinking in terms of the behavior of an end user. When an end user is coming here, what are they doing? The end user is adding a Sauce Labs backpack to a cart. So we can do something like this. So we could have a public add to cart method that can be utilized in our test, and we can have an enum that tells us which item we actually want to use. Now, by the way, keep in mind, right here what we're doing, we're writing pseudocode. Pseudocode is code that doesn't actually work, but represents real code. Just to explain to you how a page object should be coded. And so now this public method here exists for us to be able to interact inside of our test. And we can pass in a sauce item, which can be an enum. Let me show you an example of that. We can, do an enum as such. Let's add it to best practices. And then our enum can have several items in it. Maybe like backpack. Or what other items did we have there? Bike lights, and so on, just like that. And so then those can actually be passed in instead of a string, and it's also easier to read whenever we write that code. And so then here we'll have the logic to find that appropriate item, and then we'll find that element and click on it to add to a cart. Now, what you see here, what's hidden, what's encapsulated inside of this page object is this locator right here, because exposing it inside of our tests is what's going to lead to that duplication that's going to kill our test automation efforts. And so we're hiding it inside of here. Let's try another thing that we want to add here. What if we, for example, wanted to go to the shopping cart? Now, is a user able to go to the shopping cart? Yes, they are. So we can have potentially another public method that allows the user to open shopping cart. So I'm just going to copy this. And say go to cart. Get rid of that. And then here would just be finding the element and clicking on the shopping cart. Now this actually will not compile, so I'm going to leave it commented so that it doesn't break our code. But this is how we would actually do it. So one thing that I really want to warn against is filling in this entire page object before you are ready to use it. You never want to do that because you might spend a lot of time filling in all of the properties, all of the methods to interact with this page, only to find that nobody ever uses it. In fact, whenever code isn't used, our IDE will highlight it like this to gray. You can see that obviously this code isn't being used. And so then it says that there's no code using it. So we just spent all this time and all this company money trying to identify all of these elements and how to interact with them, and nobody uses the code. It's a waste of time, waste of money. It's called premature optimization, and it's something that we certainly want to avoid. The other very important thing that I wanted to point out about a page object is that usually page objects just take in a driver. So we would have a constructor here that's called inventory page. And the very normal practice to do is to pass in our WebDriver. And then we do something like this. And so then we set a driver, and then of course our compiler now complains saying this field doesn't exist. Here, if I hover over this error, look, cannot resolve symbol driver. It means it doesn't understand what this is. So we're going to use our IDE to resolve it. You can click on this little button, or you can use Control-Enter and resolve this problem by saying create field driver in inventory page. And so see what it did? It created a private field called WebDriver in here, and now we can use this driver to interact with all of our page objects as such. Look like this, and so on. And here, as such, and here. There you go, one driver interacting with all of our stuff here. This is a very common pattern. You don't need to change it. It has existed since early 2000s. This pattern works absolutely fine. I see many reinventions of this wheel, absolutely unnecessary. So this is overall what a good page object looks like. This is how you would structure it. And there is not much more to that, making sure that we only expose interactions that a user would make with our application and hide those interactions that a user would not care about in our application, such as which locator is being used to click the button or which string is being passed in for the button name, and so on and so forth. Page object anti-patterns that are sadly extremely common in the test automation space. I've worked with a lot of clients and a lot of other automation engineers where we struggle with some of these problems. One of them is overpopulating the base page. What happens is the base page must be thought of as the parent page of all the page objects. So what that means is if you want to follow the Liskov substitution principle, that's more advanced, one of the solid principles, but it really relates back to the Liskov substitution principles. It basically states that everything that inherits from the base page must do all of those actions from the base page. So it means that base page can only contain the common components that all of the pages do, not some of the pages, not like 5 out of 10 of your page objects, but all of the page objects. So what that means is stuff like the WebDriver weight class. You can throw that in the base page. You can throw a navigation method into your base page, right? To navigate maybe to the root domain of your URL, like ultimateqa.com, and then the other pages tackle, /blog, /contact us, and so on and so forth. You can also add maybe some JavaScript methods into your base page object, or common components of all the pages. And again, I like to give you kind of rules of thumb and give you practical, applicable information for you that you can take home right now and start applying it. So one thing that I've seen work really well in the past is to apply a 200 line of code max to your base page. But not only to your base page, it actually applies to all of the classes. But in this case, say that your base page can only be 200 lines of code max, and that will make sure that not only does your base page follow the list cost substitution principle, it will also follow the single responsibility principle and be small, and I'll talk about that actually in a little bit. The other problem, it's kind of the brother of overpopulating the base page, is overpopulating the page objects. A lot of individuals will start automating a web application, and instead of automating only what they need at that time, they basically throw everything into a page object from the beginning. So for example, you saw the ultimate QA page. Instead of just automating one test at a time and adding those elements to the page object, some individuals, what they're gonna do is they will start adding all of the elements and all of the methods to this class, their page object, and so their page object becomes thousands of lines long, and then a lot of those methods and properties end up not being used. And so all of effort was spent on automating and locating these elements and creating these methods, and then none of them are ever used. The final page object anti-pattern I want to talk about is having methods and properties that don't actually represent user actions. So if you remember, our classes are supposed to represent an HTML page, and that's pretty much it, representing an HTML page and how a user would interact with it. So stuff that does not belong in page objects are something like opening Excel files, connecting to SQL, converting strings to arrays, and so on and so forth. These have other classes where they should live, but not inside of the page object. So with all of that said, I'd like to play another game with you where we're going to play a game called Good or Bad Page Object. I want to see now, based on everything you've heard from me, and I'm sure you took fantastic notes, whether you think this is a good or a bad page object. Simply look at this class and tell me, write it down, think about it, whether this is a good or a bad page object. Don't worry about the implementation details. For example, don't worry about whether someone is using an ID or a class to identify an element. That's not what we're talking about here. Those are code implementation details. Look at the page object overall. Think about it. Does this page object seem like something you would understand that you would want to use in your test code? Now, I hope that you said that this is a good page object, because this is one of the best page objects that could be. One of the reasons it's the best is because I've written it. No, I'm totally kidding. I did write it, but I'm very objective with my code, and that's not why this page object is good. This page object is good because, number one, it has a really good name. When you look at this page object, Sauce demo login page, you know exactly what this kind of tests, right? You may not know what the Sauce demo page is, but you do know it's a login page, right? So right away, okay, you know this is a representation of some login page. Then you see that it has locators. The locators live in a single place relevant to that page object. That's excellent. And then you see methods that seem to belong to this page object. A method like open and a method like login, right? Login method belonging in a login page. How crazy of an idea, right? So that's why it's a good page object, because it is small, it's simple, it has a great name, and it has properties and methods that represent how a user would interact with that login page. How about this one? Good or bad page object? Now, in this case, I hope that you said that this was a bad page object. The reason why this is a bad page object is because none of us looking at this code will ever know which page it's actually testing. First, it doesn't even have a name. But second, there are no methods. There are only locators. So if anything, it's not really a page object. It's more of like a object repository. But where are all the methods to interact with this page? Do they live in a separate class? Where is that class? What is that class called? How do we use that class? These are all questions that come up right away when we look at this class and try to use it. So this one is a bad one. How about this one here? Good or bad page object? This one maybe will come as a surprise, but this one is actually also good as well. If you listened to me previously and you are familiar with page objects, this one meets all the criteria that we've talked about before. First, it has a good name, shopping cart component. Next, you see that it has elements that are relevant to the page object, and it has methods that seem like they belong in this class. So items in cart is one of the methods based on the shopping cart component. So the reason why I put this up here is to convey the point that page object pattern, even though it's named that, it's a little bit of a poor name, because a page object doesn't necessarily have to represent an entire HTML page. In fact, a page object can represent a small component of a page. And so in that case, usually we name it something like shopping cart component, right? And so you can imagine in an e-commerce site, there's a shopping cart that always lives in our header. And we want to reuse the shopping cart in all of our page objects. And so in that case, we would create a new class called the shopping cart component. The shopping cart component would perform all of the actions and store all of the properties that we want related to the shopping cart, and we would use it everywhere. Even the header as well, for example. The header, it lives on all of our pages. So rather than all of the pages constantly storing all of the properties, we create a header class. We can call it a header component or a header page object or something like that. And then that will encapsulate all of the things that are relevant to the header. Again, removing duplication so that we can reuse that in all of our classes, and then maintainability and readability all become better. I wanted to take a moment to talk about one of the most pervasive problems that I see in the world of test automation. Test automation is extremely hard, but one problem that I find consistently from my day-to-day of working with hundreds of automation engineers every single year from all over the world is an inability to understand how to break up giant classes. One thing I always recommend to everybody is to never have a class that is longer than 200 lines of code. A large class leads to tons of problems. The main one being the fact that it tends to stray away from the single responsibility principle. And another one is that the class becomes very confusing about what its purpose actually is. So it's really important to break up our page objects into smaller components so that we can have extremely maintainable code. So how do we do that? Well, that is using a concept of composition. The concept of composition is a technical concept in software development, and it basically means that we have elements that compose a class. For example, here you see an entire HTML page, right? And you can clearly see how this page is made up of different sections, right? There's this pink pie chart, there is this graph over here on the right, and there's this big one over here. It's made of different little components, also known as it is composed of many different components. That is the composition. It's a literal meaning. A class can be composed of other objects. So for example, the way it looks like in actual Java code is we can have a car class, and that car class can be composed of an engine and wheels and so on and so forth, as opposed to putting all of the operations that an engine does inside of the car, as opposed to putting all of the operations that the wheels do inside of the car. We can put them into their own classes. And so everything related to an engine will live in an engine, right? Like engine start, engine stop. It will be inside of this class. But this class can be utilized inside of this car class, and that is the concept of composition. Rather than just slopping everything into a single class, we break it up into tiny little classes that have a single responsibility, are focused on a single thing, are easy to maintain and easy to understand. So what does this actually look like for our page object? Well, it's the same exact concept of our page object. Now, the entire page is its own class, but that page can be composed of many other little tiny components. And that is how we avoid having extremely large classes that are hard to maintain. So for example, up here, you can see we have this little hamburger menu. Now, yes, you can slap this little hamburger menu inside of the inventory page, and you can add all of these links and all of the methods to interact with the links. Yes, you can slap every single one of these items inside of our inventory page and have all the interactions and all the elements to interact with it, but that becomes unmaintainable and it stops supporting the single responsibility principle. So instead we can have a hamburger menu component. This header right here can be a header component. And what can our header component do? Well, it can filter. This can be an inventory collections section, right? This can be an entire component itself. And this inventory collection, inside of it has inventory items or individual items, each one of these being its own separate class that has its own separate properties and methods to interact with. We can even have a footer that's down here that has these social media share buttons. And combining all of those together, we can perform any functionality that we want, but our inventory page class does not have to be too big. I'll actually give you a hint. I'm going to guess that for the past 5 years or so, none of my page objects or components have probably even come close to more than 75 lines of code. I would say they probably are closer to 50 lines of code maximum for every single one, and it doesn't hinder me. In fact, it just makes maintainability that much better. And so you might be asking, what would a test look like when it's actually using composition? Well, let's take a look. For example, here you can see a test using composition. Here we have our very familiar inventory page, and we are opening it just as any user can open it, or maybe even a navigate. Now, if you want to interact with the header and perform operations in the header, you simply have to instantiate a new header component and just use the header component as you want, right? If you want to search for the backpack, you just use it to search for the backpack. Or we spoke about a filter operation. You can do header.filter and do something like use an enum potentially and say A to Z or Z to A. Now, what if you want to interact with items deeply nested inside of a page? So here, for example, I have my inventory collection component. This inventory collection component, we are using it to, we are using our collection to get to some item, and we're adding that item to a cart. And this item is the hoodie item. You could also even do it another way, right? If you wanted to have the items hard-coded inside of your collection, you can do something like collection.hoodie.add-to-cart. And then each of the items has its own add-to-cart method, but the item is what differentiates what you add. Now it's your option. I'm assuming that the collection will likely expand and the store is going to get more items in it. So we can add our items to a cart in this manner because it's much easier to extend an enum versus adding extra methods to handle all of the new object, all of the new items that we may add to our class. Now, one interesting thing to note here is that why aren't we always interacting with all of our pages and components in this kind of manner? Because actually sometimes it's unnecessary. Most of the times it becomes unnecessary for us to interact with our page objects through this fluent interface. This is known as a fluent interface when you start nesting objects inside of objects. Instead, if I put a header component directly in our automated test, and we have the subject matter expertise about our application, is anybody here at all confused about what a header component does? I would say absolutely not, right? We all know what the header component does. So why can't we just instantiate it directly and use it directly rather than doing something like inventory page dot header dot search? We could do that, but we don't need to do that. And so that's one optimization strategy that I want to point out for you here, that you can just instantiate these components directly in your test and use them directly in your tests. Now, in certain instances where these components are not ubiquitous and they only belong to a specific page object and you want to make it clear which page object they are part of, that is when you will nest it inside of your page objects. For example, it might be a bit confusing if you have a test and you instantiate a brand new engine and then just say engine.start. Doesn't the engine belong to the car, right? So you want to do car.engine.start. You want to do car.steeringwheel.turn. You don't want to just instantiate a new steering wheel and say steering wheel.turn. And what is that going to be doing, right? That becomes a little bit unclear. So if there's that kind of dependency in your code, then you create that kind of hierarchical structure where a car can be composed of engine and wheels. But if you don't have that kind of a dependency, and that will happen a lot with headers, footers, sidebars, you can just instantiate those directly and just use them in your test code, and it will be extremely clear what those components are doing and where. So I hope that you were listening, because it is time to do some exercises about page objects and put your skills to the test. So here is your challenge. The goal of this task is to create me 4 page objects using Java, and these page objects must follow all best practices of page objects. Now remember, a page object has a good name that tells us exactly what is inside of the class. We should have a very easy time figuring out what that page object is supposed to represent. Page objects also have methods that a user would use to interact with the HTML page. Only an end user, not any other random methods. Okay, so those are good signs of page objects, and they are also small. Okay, so the very first page object I would like for you to create is for this sauce demo login page. Now, all you have to do is create a class that represents this page object, and I want the login method as a user would do it. So just the login method and the locators. You don't have to even get me the exact locators. I don't care about that, but I want it well organized and written correctly, making sure that all of the appropriate methods are public, all of the appropriate methods are private, or properties are private. That needs to be, so that our automated UI tests can behave correctly. Okay, so that's page object 1. You don't have to capture every object in here, only the page itself and the login method with its locators. But the locators, again, I don't care about those. Just make it up. I'm just going to put nonsense in there because that's not the point. I don't want to waste your time locating stuff. Okay, so once we are logged in, you're going to create a second page object of this products page. Okay, this products page and you're going to add me a method that goes to the cart. Okay, so this method will go to the cart, and that's it, and this corresponding locator. But again, the locators in this case don't matter, just make something up for the locator. Next, I want a page object for this cart page. So this is where all of our objects will appear once we add them to the cart. So I want a page object for this cart. And finally, when we go to the checkout page, I want a page object for this checkout page as well. Sorry, this personal information page as well. And I want a method for filling out this form. Okay, just filling it out. You don't even need to click continue. And on this one, I forgot which method I want you to add. I want you to add the method for going to the checkout process. Okay, so it'll be clicking this checkout button and going to the checkout process. So that would be the method here. Again, locators don't matter in any of these. All I want is the structure. I want to see the correct public and private access modifiers on every single method and property. And I want to see correct method names that represent end user actions that they will take on our page. Okay, so go and give that a shot. And when you come back, we'll talk about the solution. All right, so let's see how you did. Hopefully that wasn't too bad. It wasn't a very hard exercise, but was meant to help you practice creating really good page objects. So on my right-hand side, you see I've got the web page up, and on the left-hand side, you see that I have the code up, okay? So for this very first page, I decided to call it login page. I believe that it's very clear that when you hear the term login page, you know exactly what is going to be on that page, even if you didn't know this application right here, correct? But if you do know a little bit about this application, it makes it even easier. So that we got a good class name. Next, we have a private driver in here. Now, you didn't necessarily have to put this in here. You could leave your code uncompilable. I didn't direct you to do that, which is totally fine. I put it in here so that the code compiles, so that when you pull it down, you're not having any issues. Now, I do want to point out one thing. I've made this driver private. What this means is that we don't want our driver to ever be accessed inside of our automated functional tests. So that's why it's private, because we should never be able to access the driver from within our tests. Okay? Now here I have a method to get the username field. It is also private because we don't want our element locators to be exposed to automated UI tests as well. So people should not be able to use this directly, because if they start using this directly and this needs to change, it's going to cause way too many problems whenever this is used all over the place. So instead, what we do is we create a public method that represents what a user does. So what can a user do with this HTML page? Well, they can log in. So we try to represent their behavior as end users. So they can log in, and so what can they do when they log in? Well, inside of that, we actually capture the UI action. So for example, we get the username field and we send the keys that are passed in. Then we get the password field and send the keys, and then we get the button, and then we click the submit button. So ultimately, keep this always in mind. When end users come to use our application, what do they come to do? They don't come to type in strings and type in passwords and click buttons. Even though they're doing that, that's not why they come to this page. They come to Swag Labs to buy products. So what do they need to do to buy a product? They need to log in, they need to add items to a cart, and they need to check out. Does that make sense? For another example, to give you an airline booking website, right? Users don't come to the website to click a drop down, to click a date field, to click a button. They come to search for a flight, add a ticket, and then check out with that ticket, right? Those are the steps we take. And so what it ultimately means is that if we represent our tests exactly like that, the only way our test will ever need to change is when the requirements of our application change. And as long as we're in the same business line, our application requirements rarely ever change. From the inception of this application until its death, users will need to log in. And so our login test will always remain exactly the same. That's the beauty. We're minimizing the amount of work that has to be done. So now another thing that I quickly want to cover here. Why did I do this versus this and this, right? So the reason why I did this right here is because I just wanted to show you how we would normally capture fields whenever they are being duplicated. Let's say this get username field is being duplicated in multiple locations, right? Let's say it's being done and used in two places, right? Maybe in one place you're typing in a string, and maybe in another place you're also reusing this field to type in another string for whatever reason. That is how we would remove that duplication and put it inside of a method. Now, normally, if I'm coding this test without duplication, I would just leave stuff like this until it's getting duplicated. You will learn about this a bit later, but it's basically avoiding premature optimization. If this part is not being duplicated, just leave it as is. We don't need to create more code and more complications in order to hide what is not necessary to hide right now. So I just wanted to show you this example, but ultimately for now, in this case, everything doing it like this is absolutely fine. Okay, let's proceed to the next page. Secret sauce, please don't share this password with anybody. Cool, so this page, the products page. How did we represent that in our code? So the products page in the HTML, I called it the products page in our class. Again, has a private level driver. I showed you another example of a private level element being wrapped in a method. And then what do we do if we want to go here? Well, a user, what do? They can either go to shopping cart or open shopping cart. I decided to go with open shopping cart, and any actions required to make that happen would go in here. Let's say you have to synchronize on the shopping cart for some reason. You would put that action in here. And now if your application became more stable and you no longer have to synchronize, you can remove that from here, but your test remains the same. So opening shopping cart, that's all it would do, like this. So that takes us to the next page. Oh, sorry. Not that page, this page here. Here's the shopping cart page, okay? So same thing, private level driver, this, and here a user can have things in their cart, and then what are they gonna do when they click this checkout button? Yes, they will need to click the checkout button underneath, but we have to think in terms of functionality and the end user behavior. What are they doing? They are starting the checkout process. They can start the checkout, or they can just go to checkout, proceed with checkout. Any one of those would encapsulate what the end user is ultimately doing. So I call it start checkout, which represents, in this case, just clicking a button. But if more stuff had to happen, I would put more stuff inside of this method. So now finally the checkout page. So check out your information. I called it the personal information page because why? We're supplying personal information here, doing all of the standard stuff as normal, and everything is private except the only UI interactions that our end users make with our application, and that is filling out personal information, which involves this. Now, again, the beauty behind this is maybe right now there are 3 fields. Maybe in the future there will be 2 fields. Maybe in the another future there will be 10 fields. It will never matter because this is the method that we will use in our test. And we can change logic in here all we want, and this will be reflected in our 100 tests if we decide to use this method in our 100 tests. Now, and here I just decided to wrap every single locator in a method just to show you how it would look like if for whatever reason we were duplicating this line of code everywhere, okay? That's what it would ultimately look like if we were duplicating that line of code. Okay, cool. So hopefully none of that was too big of a surprise. And let's go, and I'll see you in the next video. Welcome to Automation Best Practices. Today, I'm going to teach you the ever-living, very important automation best practices that can be utilized for any type of test automation tool, whether you're using IBM Rational Robot or QTP or UFT or Selenium WebDriver or any other tool that's going to come in the next decades of test automation. Automation best practices are extremely critical because they withstand the test of time and they always apply whenever we are doing test automation. So today I'm here to teach you these skills that have helped me and the dozens and hundreds of other automation engineers succeed and rise to the top of the ranks when it comes to automated software testing. So we're going to cover automation best practices, some page objects, Selenium weights, and other tips that I'm going to show you to really take your test automation to the next level. First, we're going to talk about some automation best practice ideas. The very first thing that you need to understand and to focus on is the automation test pyramid. If you're not familiar with the automation test pyramid, it was developed by Mike Cohn a while back, and it basically says that the very bottom layer of the automation testing pyramid needs to be a majority of unit tests, and then on top of that, you're going to have less API tests, and then on top of that, you're going to have even less user interface tests. The idea of the automation test pyramid is that it basically helps you to create a good automation testing strategy for your entire automation program, right? Automation is not only UI automation. Automation entails unit and API layer and UI automation altogether. So you need to consider and focus on the automation testing pyramid. And you can see as we actually move up in different layers, what happens is the cost to develop increases, execution time increases, and possibility of false negatives increases. However, coverage does also increase and end user business relevance also increases as we move through the different layers. So that's very important to remember as we proceed through the rest of this best practices presentation. I don't like to just talk about some, nebulous topics without actually putting practical ideas and practical numbers. I love to see numbers myself, so I wanted to present you with some numbers. These are not, exact, researched, highly defined, highly statistically significant data, but this is from my experience. This is something that I've gathered over the years of working as an automation engineer, and I just wanted to show you the different types of test automation and how they compare to each other. So over here at the very top row, you can see the unit test layer. This is the very bottom of the pyramid, and why it's the most important layer of test automation to have is because you can see that a unit test can execute in as little as a single millisecond. So if you want to have a feedback loop of 5 minutes, you can execute approximately 300,000 tests. A unit test can be as small as a single line of code, and its reliability is pretty much 100%. I've actually never seen a flaky unit test because the unit test is so close to your actual test automation code that there's nothing in between your unit test and the actual code that might introduce any kind of flakiness. And so these tests are very easy to write, easy to automate. They have very few lines of code and they are extremely reliable. That's why we say that they should be the bottom of that test automation pyramid. On the other side of the spectrum, the most complicated type of automation are UI automated tests. A very quick automated test can be about 15 seconds. That's just something simple like opening up a browser and navigating to a URL and making sure that that page is loaded. A feedback loop, if you want to have one of 5 minutes, you can have anywhere from 0 to 20 tests. If all of your tests are running in 15 seconds, you can have 20 tests execute in that same amount of time. However, there are a lot of individuals, a lot of automation engineers that I work with that still struggle to even get a 15-second test. Some people have tests that are longer than 5 minutes. They have tests that are 90 minutes long. And so that poses a problem because it means that a continuous integration, continuous delivery environment will basically be impossible, because if you have a test that's 90 minutes long, you're never going to be able to deliver something in less than 90 minutes, because that's how long it's going to take for your entire automated test to finish. The simplest of UI tests can be 49 lines of code. Of course, that's plus or minus again, but again, this is just a very simple test. Opening up a browser, navigating to a page and asserting that it's open is 49 lines of code, and it can have a very low reliability of 0% to a pretty high reliability, but not still as reliable as unit tests. And the reason why there is such a big range is that there are some automation engineers that do automation not following best practices, and so they have a 0% reliability, meaning that whenever their automated functional test fails, it doesn't provide any actual valuable feedback in terms of the state of the application. Instead, what it does is it provides you a false positive, right? The test says the test failed, but it didn't fail because there's a bug in the application. It failed because there is actually a bug in the UI code logic that's being executed. But you can get it to a very high level as well. You can have 99.5% reliability. This is probably the highest level of reliability that I've seen in test automation. And what that means is basically if you execute a single test 1,000 times, 995 of those, that UI test will provide you the correct feedback, right? If it's a bug, the test will fail and tell you there's a bug. And if there's no bug, the test will pass and say there's no bug. So that's probably the highest level of reliability that I've ever seen from UI automation. And I'll teach you how to get to that level through the rest of this presentation. So I love to have real code examples, right? Again, less nebulous knowledge and more real hard kind of facts and information. So just wanted to show you some examples. Up here are some unit tests. You can see that they are very simple unit tests. They are a single line long, right? And down here, you can see a very well-written UI automated test using Selenium WebDriver. This is a nice test using the page object pattern. However, you can see it has quite more lines of code. And then under here, you can see it's using these different kinds of objects and methods using the page object pattern. And inside of there, there's even more code. While under here, there's no more code than what you see right here. And inside of here, there is more code. So basically, again, it drives at the idea that the difference between the very bottom layer of the automation pyramid and the very top layer of the automation pyramid, you can see that there's just simply more code. So it just means more time to automate the code and more maintenance time and more flakiness. So keep that in mind. So because of that, what we encounter is a commonly seen anti-pattern. It's called the inverted automation test pyramid, or the automation pyramid ice cream cone. Or sorry, it's called the ice cream cone of automation, because right, it looks like ice cream cone and then you can throw on, you know, some ice cream at the very top. And that's because people don't understand all the concepts that I just told you about how unit tests are basically the biggest bang for the buck that you get. And so what they try to do is they try to simulate end user behavior here at the top, and most of their automation is at the UI layer. And this is something that you want to avoid, because I already discussed why UI tests versus something like unit tests has a bunch of disadvantages. So after all this, you might be asking me, What are you talking about, Nikolai, right? We're all automation engineers. In fact, I myself, right, I teach Selenium WebDriver and UI test automation in a bunch of my courses. Why am I talking the automation test pyramid, and why am I discussing and telling you to do less UI automation and more unit testing and API testing? Well, it's because if you want your automation to succeed, if you want your automation program to succeed, you should follow the automation test pyramid. It doesn't mean that you should only do unit testing or you should only do UI testing. It means that you need all types of test automation in order to succeed, and you need them in the appropriate proportions. And it also means that as professionals, as automation engineers, we need to think about what we are automating, right? If we are automating a calculator functionality where we're adding 2 plus 2 and checking if that returns a 4, that can simply be done at the unit layer, right? That's inside of the code. You can check that logic inside of the code. You can even probably do it at the API layer if your calculator application is in like a web user interface, for example. That's not something you would want to do in the UI layer because there's no reason why that logic wouldn't work. However, the UI layer, you might want to do something like a login functionality, right? If you want to check that a user can successfully log in, you can use the user interface to log in as that user and make sure that he's taken through the appropriate flow. So that's what the whole reason behind me talking about the automation test pyramid is, that I want you to understand you need all layers of test automation to succeed in your automation program. Another very, very critical point about test automation, specifically UI automation, is that you always want to strive towards reliability, right? When you're trying to automate at the UI layer, the number one thing that you want to do is make sure that your UI automated tests are stable. If you want to achieve that 99.5% reliability from your UI automation and have your managers and your directors trust your automation and everybody be very happy at it, what you must do is you need to develop a test and make sure that that test is extremely reliable, right? You need to be running that test on a regular basis, daily at the very minimum, and you need to be making sure that whenever that test is failing, if it's failing, it's for a valid bug. If it's not a valid bug, what you need to do is actually stop everything that you're doing, analyze why that test failed, and fix the logic inside of your automated test to make it more stable. You can add more logging, you can add better synchronization, you can find better elements to use for your application. Those are some strategies that you can use and improve your automation before proceeding to automating more. I've worked with a lot of automation engineers, and I've even done it myself, where our managers are just simply asking us to automate a giant, massive regression suite. And so all we do is become like robots, where all we're doing is automating without actually ever stopping and thinking about, what is this automation accomplishing? Is it actually providing value to the business level, right? Am I actually providing value to the business? That's a very important goal to consider. And whenever your automation is flaky and it's not passing or failing for the appropriate reasons, it's not providing value to the business, because at the end of the day, it's not letting the business know what is the state of the application and can we release this application to production within the next 45 minutes. The other very important point here is, in order to strive towards reliability, you need to execute automation regularly, and ideally through something like a continuous integration environment. Whenever your code is being checked in, that means that your automation should be getting executed. It should be running in parallel, and it should be getting executed, and that will allow you to weed out the flaky automation from the non-flaky automation. It will allow you to make fixes on a regular daily basis and get your UI automation to a very stable level. And the final point that will help you to strive towards reliability is that you are the automation expert. And a lot of times our managers, they are fantastic people, and they have fantastic dreams in mind, and they want to automate everything through the UI layer, but they simply are not the technical experts. They cannot be the ones that are telling us to automate a suite of 3,000 manual regression tests and telling us to do it through the UI layer. That is not their job to do that. They hire us, the automation experts, to tell them what makes sense to automate and how to improve the quality assurance process of the entire program. And so you must be the expert and say, no, I will not automate this 90-minute scenario, because that is not something you want to do at the UI layer. If you want to test these different features, what I can do is I can break them up into many tiny little short tests, and I can tackle all of those together, and all of them combined will make sure that the functionality is working. But no, I will not create a 90-minute scenario. No, I will not even automate a 10-minute scenario. That's just simply something that I will not do, because I'm the expert, and the manager will understand that you're the technical expert, and they will trust you, and you need to be the champion, letting the manager know why something makes sense to automate and why something does not. I wanted to take a quick moment and tell you a little story from my personal experience that will show you the power of being the professional and telling our managers no and preferring reliability over more test automation. So there was this one company that I worked for. When I came in, their automation was in trouble. There was 2 test automation engineers on the team. One of them has been there for about 2 years, and he was automating everything. This automation engineer was an amazing guy. He was so smart, super passionate. I liked him a lot. The problem that he had was that he could not say no to his managers in terms of what to automate and what not to automate. And I think it was just a little bit of a lack of experience, and so he was just trying to automate everything. And so he ultimately ended up having a 90-minute long automation scenario through the UI. The automation scenario was actually aimed at taking an exam. And so that automation scenario would run and pretend to take an exam as a student. You can imagine how insanely hard that automation scenario is. I think if I spent my entire life there automating it, I could probably never get it to work reliably. Well, anyways, so that was the case. And that problem with that scenario was, yes, the managers did ask for that scenario. They said, yeah, can you please automate it? It would be amazing if our manual testers didn't have to take a 90-minute exam to test the application. Rather, we could have automation robots performing that operation. It wasn't feasible. It doesn't make sense. Anything over, I would say, 3 minutes of UI automation rarely ever makes sense. Maybe there is one scenario out of 1,000 that I might allow you to think to automate more than 3 minutes, but I rarely come across those. Anyway, so back on track. So we had this scenario, and they brought me in to help fix the test automation efforts there, because the project was growing, and so the amount of testing required was growing as well, and they couldn't keep up with it, right? The standard story. And so you bring in an automation engineer to help fix that solution. And so they brought me in, and they kept asking me to perform different kind of automation scenarios, such as this one, doing a 90-minute automation test, or doing other ones that were more complicated, such as almost AI-like interactions, where they wanted me to interact like real users with the application and mimic real users. And I just kept telling my boss, no, I'm sorry, this doesn't make sense. And he was not upset in any way. The reason he was asking me to automate these scenarios was because they were in his head. He had these problems, these challenges that the QA department was facing, and he was asking me to solve those challenges. What I, as a professional, needed to tell him was that in this case, it doesn't make sense to automate this scenario. Why? Because it will simply be too hard to automate it. It will cost us way too much time to maintain it, and it will never provide you valuable results. It will never fix the problem that you are trying to fix. And so after explaining that to him, he would be totally understanding. And so what ultimately ended up happening with the project? I continue to prefer reliability over more test automation. When I came in, there was several thousand automated tests, and I would bet several $1,000s that none of them could pass with a 99.5% reliability. In fact, I'm so sure of it because I worked on that team and I know how it was. And again, that's no fault of nobody. It's just a different mentality, and a mentality that I want you to change so that you are far better than anyone out there in the field and understand exactly what needs to be done. So we had that. I reduced that suite right away to maybe a few hundred tests because everything that was regularly failing, I quarantined it until further notice. Then we continued to automate only the easiest scenarios, the ones that were guaranteed to pass 99.5% of the time. And so then we could regularly start executing those scenarios. And what started to happen? My manager, he saw the power of automation and started to trust it, in which case we started to integrate with the manual testing team, where actually our automation process started to become part of the entire release pipeline, where as soon as the developer code was released, we were the first ones running automated tests. Before the manual testers spent hours testing the application, we would tell the manual testers what state the application was in and if it was okay for them to proceed in it. See that we are starting to bring the teams together in collaboration versus in silos because there was trust. Furthermore, even better, we were working with other organizations, like not even our company. There was other organizations as part of this project. This was a massive project that targeted millions and millions of users across the entire United States. So there was multiple companies involved. And these companies saw the power of our reliable automation and they wanted in on it too. They were coming to my team and they were saying, hey, Nikolai, we need your help. We would like to automate this and make this happen. We would like to do this and make this happen. And they were asking us to use our automation for their processes so that they could start validating their code that they were trying to integrate into our application. And so that is the power. Many organizations trying to use our automation to help them with their needs. That is the power of focusing on the reliability over more automation. Yes, I understand that it might seem a little bit hard to say no to your manager, but trust me, they are not asking you to automate all the things because they know that that is the right thing to do. They're asking you to solve a problem. And the way you solve problems is by providing real solutions, not by providing more automation that ends up costing more problems. And so with this story, the reason why I'm telling you is not to tell you that I'm so great, blah, blah, blah. I'm simply telling you the story to show you that this is possible and the kinds of things that it may lead to whenever you apply this approach. And how you know you're going down the right road is when you start to share your automation with the teams, other teams, not only your team. When developers want to use your automation, when manual testers want to use your automation, when managers want to use your automation, that is when you know you're going down the right path and you are doing the right things with your test automation. If that is not happening, I will highly suspect that you are likely just continuing to knock out automation because that is what your manager asks to do without actually thinking about whether that automation provides value. So thanks again. Just wanted to tell you that quick little story to tell you that it does happen in real life and I just don't only create super awesome slides. So another very common topic discussed in test automation is whether you should automatically rerun your failed tests. So what that basically means is some individuals, a lot of companies, a lot of automation engineers, what they do is whenever an automated test fails, the very first thing they do is go ahead and rerun it instead of actually considering whether it's an actual bug in the application. And that's causes several problems. First, think about the mentality that that creates for your test automation, right? If your test fails, instead of the team or even you assuming that what is the bug in the application, your very first thought is rerun it because my automation is not trustworthy. How bad of a mentality is that? That's something you want to avoid. The other problem that rerunning your failed automation automatically causes is it can actually hide true problems. I worked at a single place where I had a bunch of automated UI tests running, and randomly, like it was so random, we would have a UI test that would just fail, and I couldn't figure out why. So I spent several hours working with the developers and the ops team trying to figure out why are these automated UI tests actually failing. And after digging into it, what we figured out was that we had a website that was load balanced, and randomly, right, the traffic would go to a specific server that was load balanced based on our load balancing conditions. And when it got to that server under those conditions, that server was actually broken. And so that user that had that specific scenario would be failing. And that was a real bug in the application. Had I automatically rerun my failing test and didn't check why it was failing, we would have never caught the bug, and maybe to this day, our clients would still be seeing this intermittent problem with our web application. So my recommended approach here for your failed test automation is stop, figure out why the test automation failed, improve it by adding more logging, by improving synchronization, fixing the flakiness, and only then are you allowed to proceed with automating more. One of the most common struggles that I see with clients and other automation engineers is working actually with synchronization. In terms of UI, it's just the UI is just hard to synchronize, especially a web UI, right? So many moving components, right? Ajax components, Angular components, all loading asynchronously, elements loading other elements whenever they're interacted with. It just becomes hard. And so it's very important to talk about waiting strategies. So in Selenium, there are actually two types of waits. There is an implicit wait. An implicit wait basically tells the WebDriver to poll the DOM for a certain amount of time. And it's basically going to poll the DOM until it sees that an element is visible on the page. And it's nice because it only needs to be configured once, right? So you can see that here's a code example of how it gets configured. You basically set your implicit wait and set how long it's going to be, and it's going to live for the duration of the driver. So it means anytime you do a call like driver.findElement, that will wait for up to 5 seconds for that element to be visible on the page. Now that I taught you about implicit wait, I'm also going to tell you that you should never be using implicit waits. I actually have several very thorough articles about why you should not be using implicit waits. If you go to ultimateqa.com and look at implicit versus explicit waits, which is the second type of wait, you'll be able to find this in depth, but of course I'll cover that here. Implicit waits cause one major problem, is that they only search for an element to be visible on a page. So if an element actually exists on a page but is hidden, it's going to cause you a problem, because your test is going to say that the element is not there when in fact it is just simply hidden. And so it's going to cause you a bunch of flakiness. And then the other problem with using implicit waits is, again, I have a topic covered this on the blog, is Jim Evans, actually the creator of the .NET Selenium bindings, tells us that you should not mix implicit and explicit waits, because what it's going to do is actually lead to undefined behavior in the different browsers. Different browsers implement implicit waits differently, so how an implicit wait behaves in one browser may be different from another. And so mixing implicit and explicit waits is going to cause problems and should not be done. And so if I just told you that implicit waits cannot always give you the solution because they only tell you if an element is visible on a page. So if an element is hidden, it means you're going to need to use an explicit wait. And if you need to use an explicit wait, it means you can't use an implicit wait. And so the only solution is to use explicit waits with your Selenium test automation. Explicit waits are the code that you actually write to wait for a certain condition to occur before proceeding. These are very versatile because it can allow you to perform many different kinds of waits on an element before proceeding. So here are some examples that I actually have. You can see that up here I have an example one. This is the recommended approach that actually Selenium provides. So you can see we create a WebDriver wait class. We pass in how long you want to wait for an element. And then we use the Selenium's expected conditions class to see that an element is visible. So that's one example. And this expected conditions class makes life for us much easier because we can just use it to check for different states of elements. And here's the expected conditions class you can see on the right. From Selenium, you can check many different kinds of properties and the different kinds of states of elements to make sure that, you know, the element is in the appropriate state. Here's another more complicated wait that you can do in, an explicit wait that you can do here. You can see that we're configuring and creating a WebDriver wait, and here we're actually writing our own code to wait until some specific condition occurs. And here is a third example of an explicit wait as well. This is the code that we wrote. However, it's a thread.sleep, and this is the worst kind of wait and almost should never be used. I've seen two good use cases for using thread.sleep. One of them is when you actually need to wait for an event in an application. So for example, let's say I've seen one use case where a user filled out your username and password and then they logged in, and then they had to wait for like 40 seconds before proceeding into the application. It was like in the UI. So that's one good example of using a thread.sleep right there. Another great example is sometimes Selenium is extremely too fast for typing strings into our fields. So I've seen it actually be a good use case where you can create your own method to type more slowly utilizing Selenium WebDrivers. You can grab a string, you know, break it up into multiple characters, do a for each loop, iterate through every single character, and as you iterate, just do a thread.sleep in there of like 500 milliseconds and slow down the Selenium typing. That's the two good use cases that I've seen for thread.sleeps. Other than that, there are no good use cases. You might convince me of some other good use cases. If you've seen them, please come to ultimateqa.com and talk to me there. I'm always happy to learn, but so far, those are the two that I've seen. All right, so let's walk through some actual code and see what the synchronization stuff is really about. And I really want to emphasize here, this is a very small topic, but it is extremely confusing. I would say that 99% of the automation engineers out there in the world that I interact with don't actually understand the difference between an implicit and an explicit wait and when to use one over the other. So I will actually show you that so that you understand it and you will be the 1% that actually understands when and how to use implicit versus explicit waits. Okay, so we are in this class synchronization, okay, and I'm gonna walk you through a bunch of tests that show you the different concepts. So inside of this class, we have our standard driver that we're always using, and we have two URLs that are important. There is a URL where the element exists in the DOM always, and then there's another URL where the element is rendered after we click the next button. Let me actually show you these applications. So here's the very first one where the element always exists. So if I do inspect here and we look at this element right here, finish, you can see that this finish element already exists in the DOM. So the goal here of this one is you click the start button, you wait for a synchronization, and then you wait for the finish message. See, you wait for that, right? So a very standard situation in test automation where we perform an action, we wait for a synchronization period, for example, taken to the next page, and then we synchronize on some element. That's very standard. And so this one always exists in the DOM, okay? That's this one here, and I've labeled it as this string variable right here. So it's very clear. Part 2 is this element doesn't exist in the DOM until the start button is clicked. So you can see here that if we search for this, I'm going to do Control F to search for this, and then we search for ID. I forget, what was it? Here I had it finish. You can see that it doesn't exist. It exists in this JavaScript function, but it doesn't exist in the HTML. I only have a single element, okay? So when will it exist? Let's watch. After you click the start button, clicking the start button creates the actual element. A very, very common scenario in today's world. So now if I research, you can now see I've got 2 of them, and here is that actual element being highlighted. Makes sense? So the first one, element always exists in the DOM. The second one, element is created only after we click the next button. Okay, it's a very important difference here. So, okay, these before and after hooks are standard, just setting up and cleaning up test driver. So let me show you what happens when we have an implicit wait configured. So this is default out of the box. Our synchronization is already set, and what is going to happen when we call the find element method. Let's run it. And we're going to run it on the element existing in the DOM, right? So it checks, is the element existing in the HTML? And look, the test comes back as passed. You know what that means? That even though the element is not visible and our application did not trigger the functionality that we found the element, and so that is a false positive. Let's take a look at what happens when we look at the page where the element is rendered after clicking the next button. So if we're checking for this, watch. Let's take a look. See the difference? This test failed, and this test throws a no such element exception, telling us that no such element exists, and then it gives us the locator of that element. Look, this locator that we tried to look for, okay? And so what does this mean? It means that if we clicked the button and we try to check for that element, it would have failed, as it should have, because we never clicked the button in this test. In this test, all we did was open the URL and search for the element. That is the expected behavior. This is not the expected behavior because we never clicked the button. Do you see the difference there? That is the fundamental problem with an implicit wait, is that if your element exists in the HTML, it will always find it, regardless whether you performed any action or not. So if you're trying to synchronize on some important action, did a user submit a form? Did a user log in? Did a user click a button that generated another element, and that HTML element exists in your DOM, you will always get a false positive, and the find element will always come back as true. It will find the element. That is the fundamental problem. So let me show you one other thing. So the way you know you're using an implicit wait is just by setting an implicit wait as such. That is it. You know you're using an implicit wait if you're using this line of code. Done. Nothing else beyond it. If you didn't use this line of code, you don't have an implicit wait set. Okay? So watch what happens when I set it, and I set the timeout to 5 seconds. And we're going to check this page to see the element rendered after. So watch what's going to happen. Is it's actually going to check and wait for the element. It's going to poll several times. It polls every 500 milliseconds for that element, and then it will fail. Picking up which kind of an exception? No such element exception. Look at this. We're going to scroll down here. I'll show you. No such element exception. And did you see how the page took longer to load? It waited for 5 seconds, said there's no such element because we never clicked the next button and we never generated the element. And then we got a no such element exception. Okay? Makes sense? So that is the fundamental problem. So I just want to summarize just to make that clear. Do you see the fundamental problem with an implicit wait is that if we have hidden elements that always exist in the DOM and we try to synchronize on those elements, we're going to get false positives with the implicit wait. Hence, we cannot reliably use it for our find element calls. And so that's where an explicit wait comes in that will help us to resolve those problems. And in an explicit wait, we specify some specific condition that we want to use to wait for an element to be on a page. We specify the condition versus an implicit wait specifies the condition and we have no control over it. So let me show you this class right here. So we have this test. It says explicit wait fixes implicit wait issues. And I am expecting an error here. Timeout exception from Selenium. This means that this test should throw this timeout exception. If it does, it will pass. So what does it mean? It means that we will navigate to the URL where the element exists in the DOM. So implicit wait was giving us back a false positive and saying, yes, I found the element, even though we never clicked the next button. However, we're going to use our explicit wait, which is here we're using the WebDriver wait class, which is provided to us by Selenium. This is how you instantiate it. And then we're going to use expected conditions, which are also provided to us by Selenium, with a bunch of different expected conditions. In this case, we're going to say that I'm going to wait for the visibility of an element located by our locator, which we have been using throughout, which is by ID finish. Do you understand? We're waiting for the visibility of an element. So if I run this test, what do you believe should happen? Pause this video, think about it, and when you get back, I'm going to tell you the answer. Okay, let's run this test and see exactly what happens. So if you said that this test is going to run, wait for 5 seconds for that element, even though it exists in the HTML right now, it will wait for 5 seconds and then it will throw an exception. And you see how it passed? Because it threw this exception because the element was not visible. So our wait until timed out and we got an error because the element wasn't visible. Yes, it existed in the DOM, but we don't care about that because we want the element to be visible. And so that is how an explicit wait fixes our false positive problem. Let me show you a bunch more expected conditions that you have available, and you can play around with all of those. So here's the expected conditions class from Selenium. Let's take a look at all of the expected conditions that we have available. So you can check for presence of element, visibility of element. You can check for visibility of all elements. You can check for another visibility of all elements where you can pass in a collection of elements if you don't want to check just one. There are so many more. Let's see. You can check for text to be present in an element. You can check for text to be present in element value. There's so many more. Invisibility of an element. You can wait to click on an element and wait for some element to disappear. You can check for an element to be clickable, right? Maybe you are filling out a form, and until you select the drop down, the next field will not be activated. And so you can wait for the element to be clickable before and make sure that it is before interacting with it. So many conditions here. In fact, pretty much my entire career, I've never needed to write my own expected condition because Selenium provides us the majority of what we need. There may be a few rare instances where we need our own conditions, but the majority of the time, expected conditions is solid enough to solve most of our problems. So I would say you try different expected conditions, and then if you find out that that is not sufficient, at that point you implement your own. So in this test over here, where the element exists in the DOM, okay, same test as before, but here, rather than checking for the visibility of an element, we are checking for the presence of element located. What do you believe will happen when I run this test? Think about it for a moment. When you come back, I will give you the answer. So checking for the presence of an element is exactly like doing an implicit wait and a find element call. It will come back as passed because the element is present in the DOM. The element is present in the DOM, and so you can see the test came back as passed because the element was found. Now, if we reversed this, and rather than going to the element exists in the DOM, we went to element rendered after, what do you think would happen? And we checked for the present. The same thing would happen as with an implicit wait. It would fail because it would say the element is not there, which is the expected behavior because we haven't clicked the next button. The element has not been generated. We don't want the test passing until we find that element. So hopefully all of that makes sense. That is the difference between an implicit and an explicit wait. And so as you see, implicit wait is not efficient enough to solve all of our automation problems. Hence, at some point, you have to use an explicit wait. As a result, we get to the most important rule of this. Let me show you a quote from Jim Evans, the maintainer of Selenium C# bindings. He says, "Don't mix implicit and explicit waits." And the reason why you don't want to do that is because you're going to get into undefined territory where even he doesn't understand the behavior of how Selenium will behave. And so, because of that, if you can't mix implicit and explicit waits, and implicit waits are not sufficient enough to fill all of your automation needs, that means that you should never use an implicit wait. You should only use explicit waits. And I actually have an amazing use case where I worked with a client who was mixing implicit and explicit waits and had a lot of flakiness in their test automation. I simply had them remove a few lines of code from their test automation, which were just doing the implicit waits, and they got a 2000% improvement in their test automation stability just from removing a few lines of code. Just by removing implicit waits, replacing those with a few explicit waits, they had a 2000% improvement. Again, because they had that undefined behavior that simply nobody could figure out. They had the flakiness. So that is the most important lesson of this entire section. So let me tell you some other tips that are phenomenal for test automation. This doesn't mean that they are not important at all. In fact, this whole presentation is about an hour of some of the greatest tips that I can ever gather. If you know me, you know that I can talk about test automation for days. Literally, I can just sit down with someone and just talk about it for days. And so when I give this presentation, it's about how can I give you the most value in this, short little 45 to an hour minute presentation. And so these are all my best tips that I could gather. So don't think that anything in this section is less important. One of the very most important automation best practices, and this is just a coding best practice in general, but right, as we all know, automation involves coding, and a lot of times you can be considered as software development engineers in test, and so coding is very important, and that principle is not to repeat yourself. And as you can see, Bob Martin here says that duplication is the primary enemy of a well-designed system. If you're not familiar with Bob Martin, he is a phenomenal software developer. The guy is just so smart and so knowledgeable about everything. And you can see he has a wiki page, so he's pretty important. But if you haven't seen him, I strongly recommend go on YouTube, search for him, go on Google, search for him, and watch some of his presentations. This guy is just mind-blowing. So if you listen to anyone, you can ignore everything I say, but definitely listen to him. So the problem with duplication, right, is that it causes us extra work whenever it's time to change, right? Change in software is inevitable, but how we deal with that change and how we prepare for that change is what is important. And so if we decrease the amount of duplication that we have in our test automation code, whenever that inevitable change happens, it will just make our life much easier for handling that change. So duplication can occur at multiple layers. One of the easiest ways to find duplication is it's simply hard-coded and created in our actual test automation code. So here you can see I have a bunch of elements that I'm reusing over and over, right? So whenever this element locator changes, for example, I now have to come to this single test and update these locators here. And there's just a single test, right? Imagine if you have a suite of 150 tests. Now you got to find these locators. So you can avoid this duplication simply by putting this locator into a property of a page object, right? Call this the user email property, right? And that will return you this element. And then you can call this the user password property, and that will return you that element. And so whenever they change, all you have to do is go to that single location in your page object, update it there, and now that will be reflected in your 150 automated tests. Duplication can also occur at even a higher level, right? It's not as obvious if you're just looking at the code like this, but if you look from test case to test case, you can see that we actually do start having some duplication, right? Some repeating logic inside of your automated tests. Initializing some driver, there's some try-catch block. In here, we're doing some common stuff. In here, we're doing some common stuff that's the same as up here. So you can even encapsulate all of this logic and abstract it up into a page object as well. And so, for example, if you were using a page object, this is actually using keywords, right? Keyword-driven testing, right? Keywords are equivalent to methods here, right? And you can see this is keyword-driven testing, a bunch of keywords combined together to create it. That's a problem actually I have with keyword-driven testing. But if it lived inside of a page object, for example, this logic right here seems like it's a login, right? Go to my account link, type username, password, and log in. So this is a login. So here we, open courses page, coursespage.open, and then here is coursespage.login. And so now you remove, what is this? 7 lines of code and put it into a single method here, 7 lines of code and put it into a single method here. And so whenever this logic changes, right, maybe we add a CAPTCHA somewhere here along the way. And if you need to add a CAPTCHA now, you just update that one single method, login method, and that will be reflected in all of your tests as well. Another very important point, again, stolen from the awesome guy, Uncle Bob, is he says that the first rule of classes is that they should be small. The second rule of classes is that they should be smaller than that. I love that because it's so true. And the reason why you want to keep your classes and methods small is that it helps you first to follow the single responsibility principle. You'll notice, and I promise you, if you try this and just listen to my advice, if you just try it, you don't have to follow it, but just give it a try. When you have small classes and small methods, what happens is your classes and methods start following the single responsibility principle. And the single responsibility principle of the solid principles tells us that a component should have only a single reason to change. And of course, when you have less code, it makes it that much more possible. Also, keeping classes and methods small allows you to have them very focused and not lying about what they do inside. Let me give you an example of that. So take a look at this method right here. So what do you think this method does, right? If we just analyze the method signature, well, it returns some kind of a string, right? And it's called getLanguageInUse, and then it takes in some content, and then it takes in an expected language. So it looks like maybe you're passing in some content, and then I guess you might be expecting some language from that content, and it's going to tell you what that language is in use. I guess we don't know if it's like a math language or an English language or like programming language. We don't really know that from here, but okay, that's what I'm assuming. You know, maybe I'm interested to know your thoughts. Let me know at ultimateqa.com what you thought this method was doing. But now that we have a notion about what it is, right, and we see its usage, we see its definition, when we actually open it up, this is what it actually does. Let's take a look inside. So it's trimming some content, okay? Then there's some ranked language identifier factory that's being created, and then we're getting some kind of a pass and creating some XML. Then we're loading something. Then we're identifying something, okay, language, and then there's a most certain languages, and they're getting sorted first or default. Then there's something with these ISOs that's being determined whether it's English or Spanish, and then somehow, okay, we're overriding it. Wait, but then there's overriding a math language? What? So this is craziness, right? I think you would agree with me that when you look inside, you are so confused by what this method is doing. And so the method signature lied to us about what the method actually does. And when we looked inside, we just got confused. But not only did it cause the confusion, this obviously doesn't follow any single responsibility principle, because I don't even know what a single responsibility of this method is. So maybe something like this is better. So this is, again, a small method that I've decreased. This was actually from a real test automation project I worked on. I've decreased this method in size to see if it can better represent exactly what it's doing. So pretty much the same, but in this case, you can see we're returning a language type instead of a string, just an enumeration. And again, we're passing in a content, and we're passing in an expected language, which is set to no language determined by default. So we're trimming our content. Then from our content that we trimmed, we're determining the language, that the language get returned. And then if this condition right here is met, then we override the unexpected language that we got, and then we return it. Otherwise, we return the language that we got. So if we got an unexpected language, we override it, but otherwise we return the language. So does this make way more sense when you look at the method signature and what the method actually does? That yes, this method actually does tell you the language that is being used from the content. And so again, that's the power of making classes and methods small, is that they don't lie. But also this has a single responsibility, right? Because if anything related to determining the language from your content changes, we know exactly where to go to change it. How about this class right here? What do you think? Is this class too big? Well, this is a real class, you know, taken from a real software development project. And what is the problem with this class? Well, again, it's multiple problems. First, it's called the super dashboard, and extends a bunch of different stuff. So when you think of what does super dashboard actually mean, I myself don't know. It could mean multiple things. But then when you start looking inside, you can see it does many different kinds of things. Like it's getting customized language paths. It's getting some kind of states. It's getting some kind of a project. It's setting focusing. It's deselecting objects. It's getting configuration managers. It's setting titles. It's running a project. It's updating display layer. It's creating layouts. This does way too much. It does not follow the single responsibility principle. But not only that, it's just confusing because when something changes, where do you go to fix that change? Do you come to this class? Maybe a method that changes in here, or maybe it's somewhere else. But when you also need to add something to your project, to your software development project, to your test automation, where do you put it? Maybe here or maybe somewhere else. It's so confusing, nobody knows. And so that's the importance of making sure that your classes and methods are small. Oh, and I also didn't mention, again, I try to provide you less nebulous information and more actionable. So again, we already talked about this. My recommendation that I've seen work really well from the past, and I actually got this idea from Uncle Bob, is 200 lines of code max for all of your classes, period. Give it a shot. You know, it might not work as well for you as it did for me, but maybe it will work fantastic. And then you don't have to reinvent the wheel that I've already went through and trying to figure out what is a good size for a class. Give it a shot. And for methods, actually 7 lines of code, you know, plus or minus, plus maybe a line or two in rare cases, is a great amount. So that means actually from the method signature all the way down to the last brace, 7 lines of code is a great amount for the method. What it's going to do again is it's going to make sure that your methods follow the single responsibility principle, and your methods are going to do exactly as they say they will do. And so give it a shot again. I've seen it work really well. It might not work well so well for you. If it doesn't, just adjust from there. But again, I'm giving you a starting point, somewhere to jump into and be like, okay, let's set these rules up right now and just give them a try. It's a framework, and then if they don't work out, adjust them for yourself. But come back and let me know how it works out. I'm really, really interested to know how these rules work out for you, because they've worked out really well for me in the past. ultimateqa.com, come and talk to me there. Hello friend, and welcome to the end of the automation best practices section. We had such a great time learning some of the most popular and most important automation best practices. Test automation is extremely hard, and there are so many automation best practices to learn. In this section, I've provided you some of the very most important ones, but there are many, many others out there. Some of the top ones from this section that I would recommend you always keep in mind, even though all of these are critically important, is always be thinking about the automation pyramid. We learn how the automation pyramid is critical to making our test automation successful. We always need to be thinking, how can I bring our test automation to a lower level? How can I do more unit testing and more API testing so that I can decrease the amount of UI testing that I do? In fact, doing more unit testing and API testing will actually make our UI automation more stable and perform better as well, being able to actually be used in the test automation pipelines and creating continuous integration, continuous delivery environments. Also, don't forget to always use page objects. Now, there are many other patterns out there. People continuously attack and try to reinvent the page object pattern. There's absolutely no reason. Martin Fowler came up with the page object pattern, and it continues to be the easiest pattern to follow without needing much complication. It is just so simple and straightforward that we don't need to deviate. In fact, the page object pattern is not the main problem that we should be trying to solve in test automation. So just stick with the simple pattern. Avoid trying to get away from it, and I promise you that you will be able to solve other challenges that are more impactful for your test automation. Finally, we learned an extremely important lesson in terms of synchronization. I'm serious when I say, and I don't exaggerate, 99% of people don't understand when to use an implicit wait and when to use an explicit wait. I travel all around the world and work with dozens of clients every single year, and that means I interact with hundreds of different automation engineers every single year. And most of them continue to mix up these two simple ideas. And the point here is only use an explicit wait when it comes to your test automation. Explicit wait will allow you to synchronize correctly. Explicit waits will make sure that you're checking for the appropriate condition for your element state, and when you won't be mixing implicit and explicit waits and creating insane instability in your test automation. Also, explicit waits, what they actually allow you to do, and you don't have to use them all the time for your every single locator. What I actually recommend is that once you've synchronized on an element on a page and that page is rendered, it is most likely that now you can just continue with your driver.findElement calls. Do not use an explicit wait for every single element on a page. Let's say that a page loads up and there's a form. You fill out a form and that renders some new component. Synchronize on that new component, and now you can just simply do driver.findElement, 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 and do your interactions. The explicit wait is only good for the synchronization point. When you're bound to have some instability in your UI, only use it then.